city building and the practice. In the second session, we have covered the water quality aspects, wastewater management and the resource recovery. And in the third session, we have discussed about the effective operation and maintenance for utility assets and the management 24/7. And now on the second day, we will start with the theme circular economy for strengthening urban water management, policy governance, approach, technologies, capacity building and practices. In this session, first of all, I request Engineer Anil K. Gupta, Honorary Director, Technical of the Indian Water Work Association to chair the session. Please come, sir. And the speakers for this session, I invite them also. Mr. Vishwanath S., Advisor, Biomi Environmental Trust. Mr. Dipender Kapoor, Director, Water Program, Center for Science and Environment, New Delhi. Mr. Ajit Saudi, Chartered Civil Engineer. Senior Vice President, NJS Engineers India Private Limited. Then Mr. Jadhav, Abhishek Jadhav, Team WS2 EPL. Yeah. And Mr. Sagar Patil, Senior Technical Officer, All India Institute of Local Self-Government and Regional Center for Urban and Environmental Studies, Mumbai. And Mr. V.K. Sawant, Chairman, IWWA, Goa Center. So now I request Dr. Anil Gupta, Engineer Anil Gupta, sir, to take the session charge. Thank you.
Hello, very good morning, learned speakers and delegates. So this is there are six speakers in this session. I will request each one to take 15 minutes to present their lecture. And we know this session is very important from the point of view of the water scarcity in the urban areas. Rapid urbanization, population growth, all these factors make the situation very difficult. So we should go from the linear process, linear system to circular system. And we should consider the waste as wealth. So in this motto we have to work, and I hope that today's speakers will focus this point, which is very essential, keeping the scenario, present scenario as global, the whole global, specific and South global. Thank you. So first I invite Mr. Vishwanath S. Advisor. Let us brief about Mr. Vishwanath. Vishwanath S. is an esteemed environmental advocate and expert, advertising the Biome Environment Trust in Bengaluru since 2000, with a background in environmental engineering from NIE Mysore and a master's in urban planning from CPT Ahmedabad. He excels at bridging urban development with ecological concerns. His influence extends as an advisor to Argyan Foundation and Indian Water Portal, championing responsible water management. As the Rainwater Club's founder, he leads impactful rainwater harvesting initiatives, preserving this vital resource. Furthermore, Vishwanath holds the vital role of Secretary General at the International Rainwater Catchment Systems Association, contributing significantly to global efforts in sustainable rainwater utilization. Mr. Vishwanath. please.
Thank you. It's always good to begin an innings on the second day. So what I've been told by the chairperson is 15 minutes. I'll be happy to share 5 minutes of my time with the fellow esteemed panelists. So I'll hope to finish in 10 minutes. Certain ideas which I want to bring forward to you on circular economy and how it's being perceived in the Indian context. We all know what circular economy is. It's trying to put not a linear pass-through for water, but to engage in getting back the water, the nutrients, the energy from wastewater or used water and put it into a loop. So my presentation today is on a small town called Devanhalli, where the international airport at Bangalore is located. It's about 40 kilometers from Bangalore city, Bangalore being the capital of Karnataka state in South India. The Bangalore city itself is 14 million in population and rapidly growing. And I'm going to talk to you about how Bangalore city is connected to Devanhalli town through the circular economy. So it's called integrating shallow aquifer to the water supply system through managed aquifer recharge. What I have not mentioned here is that the managed aquifer recharge is also through treated used water. So managed aquifer recharge through treated used water. One of the key factors of a major metropolis right now, which one observes, is that Bangalore city, for example, is constantly looking at setting up sewage treatment plants, which are smaller and smaller, what we would call decentralized. Initially, the first set of 3 sewage treatment plants in the city were about 270 million liters per day, 400 million liters per day. Increasingly, they are becoming 15 million liters to 40 million liters per day. Because as the city expands, watersheds are found and wastewater treatment plants are located in watersheds, which would have a catchment which would normally be about 15,000 to 40,000 people. So decentralization is an ongoing process, decentralization in the sense of smaller and smaller wastewater treatment plants. We now have 35 wastewater treatment plants and another 20 under construction. So the city itself has 55 wastewater treatment plants. In addition, there are about 3,500 decentralized wastewater treatment plants in apartments and gated communities. I'm going to talk only about the city's wastewater treatment plants, which is geared to treat 1,390 million liters per day. Currently, 1,390 million liters per day is the capacity of the treatment plants. This is just to give you a sense of the kind of valleys we have and the treatment plants that are there. The yellow is marked in particular because from 3 treatment plants of the BWSSB, water is being pumped north to fill 65 lakes of the neighboring drought-prone district. These yellow ones are of clear interest to us, but just to give you a list of these 33, 2 are now being refurbished, so 35 wastewater treatment plants, 1,381.50 million liters per day, varying technologies from MBR, MBBR, SBR to ASB. So let's talk about this, how is Bangalore city being linked to Devanhalli town? There's a project called the Hebbal-Nagwara Valley project. It's called the HN Valley project. The intent of this project is a combination, is a partnership between the Bangalore Water Supply and Sewerage Board and the Minor Irrigation Department of the Government of Karnataka. So the Minor Irrigation Department of the Government of Karnataka treats secondary treated wastewater as a lift irrigation project and lifts the water from these 3 STPs to fill 65 lakes in the districts north of Bangalore. Chikballapur is the name of the district. It's a drought-prone, climate change affected district, where groundwater tables have plummeted to 1,200 feet and beyond. So everything is automatic now, so I'm not in charge of this. So, yeah. So there is the treatment plant, 210 MLD treatment plant, a 3 set of treatment plants with treated wastewater is being pumped north and filling up lakes like that. What you see is a blue pumping station, and that's the way the treated wastewater flows into the first lake. This is how lakes are filled. You see the inlet point of the treated wastewater. This is now 42 kilometers distant from the city. It's flowing in through the channel, fills the tank, as it's called. The lake is called a tank in our part of the world. Then it overflows, as the figure on the right, cascades down by gravity and fills the next set of tank. So about 5 to 6 tanks are filled by gravity. Then again, there's a pumping station set up. Then it goes to the ridge line and starts filling up the next series of tanks. So it's a combination of gravity and pumping. The initial is pumping from the sewage treatment plants to the first lake, as you see here. So that's the delivery chamber as it comes. So this figure shows you the number of lakes or tanks in the particular district of Chikbalapur, of which the pink colored ones are the ones which are being filled by the treated wastewater. These are the major tanks which have a command area of more than 40 hectares. They belong to the minor irrigation department, and these are first chosen for filling with treated used water. So on the figure on the right, you see that small 3 dots at the bottom, 3 squares. That's the wastewater treatment plant in Bangalore. Bagalur Lake, which is about 18 kilometers away, is the first lake to be filled with treated wastewater. It's diluted with rainwater there. Then you see an airport, a plane there. Next to the plane is Devanhalli Sihinir, where this treated wastewater comes in from Bagalur Lake and is further diluted with rainwater, right? So there's a double dilution of treated used water with rainwater in these 2 lakes. And this, again, captures the number of lakes in Chikbalapur, more than 2,500, of which only about 65 are currently being filled. Only 65 are currently being filled. That's Devanhalli town as a location. This is where the international airport has been situated. Small town, 40,000 population, old history, more than 500-year-old history of the town itself with a large fort. That's the Devanhalli fort area built in 1501. Next to it is Sihinir Kere, this freshwater lake, which is the only source of fresh water there. See the gentleman washing his feet on the right. Behind him is the lake, as it looks like, absolutely bone dry. No water for 14 years in a bad condition because the watershed was not connected to it through the feeder channel. So that's the lithology of the area. The lithology of the area is very particular. It's up to about 40 meters is weathered rock. 40 meters is weathered rock. That's the shallow aquifer, or the unconfined phreatic aquifer. Below it is hard rock. The particular condition of Devanhalli with the lithology is that any deep borewell water is extremely saline. The TDS goes up to 1,800 to 1,900. The shallower your water table, the sweeter the water is. Open wells have sweet water, about 350 TDS, but deep bore wells have 1,800 to 1,900 TDS. That's because of the lithology of the particular area. That's the set of bore wells that the town is now using, more than 110 of them, which have gone to a depth of 1,400 to 1,800 feet in some cases. Extremely saline water, supplied once in 9 days. The fresh water which the town people are drinking comes from RO plants. There are 14 small RO plants, reverse osmosis plants, where you pay 5 rupees for 20 liters, and that's how you access sweet water for drinking and cooking. This is the condition of the lake, next to the lake, before the intervention happened, and the lake was desilted and linked to its channels. This is how the lake looks like now. The lake is full of rainwater and treated used water coming from Bangalore. The lake criteria is defined, meets A, B, and C. Normally it varies from A to C. Typically C is the minimum standards of the waters of the lake, which is ensured through testing and making sure that the water quality is at C, right? So it's with treatment, you can supply the water for drinking purpose. That's how the well looked like next to the lake, an old open well, more than 100-year-old heritage structure, full of garbage and trees growing in it. This is how the well looks like once it's been cleaned up and desilted, now connected to the lake through the shallow aquifer. The lake fills up, the well is about 80 feet away from the lake, so it's aquifer recharge, which is bringing water to the well. That's how the well looks like. When you check the water for BIS 10500, it meets all potable standards except for fecal coliform, as is to be expected, E. coli and fecal coliform. So a set of 2 filter bore wells were dug next to the open wells. Filter bore wells go only 80 feet, have perforated casings, unlike deep bore wells. So these 2 filter bore wells were dug. The well was brought back to life, a water treatment plant set up next to it, and meters fixed to understand what the quantity of water can be pumped up from the shallow aquifer, and also to understand the quality of water. The treatment process, as determined by the quality of water tested in the filter bore wells and open wells, required the setting up of a 130 micron disc filter, a multimedia filter with activated carbon, UV sterilization, and online chlorination. This was the 4 steps taken to ensure that it meets BIS 10500 norms. That's the flow rate and the design schematic. It's designed at 15 meter cube per hour from the open well. From the filter bore wells, it's about 4 cubic meter per hour. Chlorine dosing, UV systems as is there. And so, again, just to say that we are learning what the multi-grade filter should look like, we are now more confident it should have more activated carbon. We need perhaps more of an activated carbon filter. And residual chlorine dosing, we are learning that the contact time needs to be increased because we are testing the water for fecal coliforms. So the water available from the two filter bore wells, we need to estimate how shallow aquifer behaves. What is the rate of recharge into the shallow aquifer? What is the sustainable yield from the shallow aquifer? What is the extent and storativity of it? All those are being tested out to figure out what is a sustainable yield from the shallow aquifer. And so this testing has stabilized at 175 kiloliters per day. It has the potential to go up to 250,000 liters per day from the open well itself. And one of the fascinating things was the cost involved. So what we figured out from the pumping costs and the operations and maintenance cost is the cost per kiloliter from the open well is 1 rupee 54 paisa per 1,000 liters. 1 rupee 54 paisa per 1,000 liters. The embodied energy is about 0.1 unit per cubic meter, which means that the water from this open well and the filter bore well, after treatment, is the cheapest water, is the water with the lowest energy consumption and with the lowest carbon emission. By using treated wastewater, you're doing climate adaptation, because treated wastewater or wastewater is climate-proof water, as we talk about in our community. And once the shallow aquifer comes up, it uses very less energy for its pumping and use, so therefore very less carbon emissions. These are the two striking factors that are emerging from it. So there you see it, the energy per kiloliter, 0.25 per kiloliter, 0.19 and 1.79 as compared to deep bore wells. And deep bore wells have a quality issue also. So there's a significant reduction in energy consumption and carbon emission, significant improvement in quality of water being supplied. And so these are the parameters. They're being checked right from the sewage treatment plant. We're checking for BIS 10500 for treated wastewater, not the wastewater norms as specified by the NGT, the National Green Tribunal. We're checking for BIS 10500 from the STP to the first lake Baglur, to the second lake Sihinir Kere, the well, and then the treated wastewater. So this protocol is in place. It's being done by the Indian Institute of Science. And at every point of time, we're meeting BIS 10500. We are sure and confident that this project, which is in its second phase, can be expanded to about 1.2 million liters per day, being a very major supplement for the town of Devanahalli. And wherever this treated wastewater is now entering the lakes around the districts of Kolar and Chikballapur, which is 200 lakes, there they can become, we are confident with absolutely good design and with good water treatment plants, that they can be sources of water for gram panchayats, small towns, and even large towns as a supplemental water. Insofar as we know, this is one of the first projects of managed aquifer recharge using treated wastewater for domestic water supply for a town in India. And our learnings are just 160 days old. We want to progress with this learning and knowledge building so that we're able to replicate it in other places. Thank you very much for your time, sir. And this is on.
Thank you, Mr. Vishwanath ji. You elaborated the replenishable of a lake in Bangalore, which was being dried up due to extraction of groundwater. Similar case I observed in the Chennai Parur Lake. In Parur Lake was also replenished by the treated sewage water. Similar case. It is a good topic. Now I invite next Mr. Dipendra Kapoor, who is the Director Water Program in Center for Science and Environment, Delhi. Mr. Dipendra Kapoor, a development and WASH expert, presently services as the Director of Water Program at the Center for Science and Environment. With an impressive career, he has held key roles teaching SU Nara University, serving as country representative for Water Aid and leading initiatives at CARE, Oxfam WSSCC, SPWD, and AKRSP. His contributions extend to leading the sanitation capacity building platform at NIUA, crafting national strategies and pioneering framework for capacity development and resilient urban sanitation response effectiveness. Additionally, he played a vital role as the sanitation lead for the PMU of Swachh Bharat Mission Urban and served as the country representative of Water Aid India. Mr. Dipendra Kapoor, please.
Good morning, and I'm very grateful to IWWA for this invitation. I also feel very happy to be presenting whatever I can for this session on circular economy to this esteemed group of experts and practitioners here. So my presentation, unlike Vishwanath's, is a little generic, but it also includes some of the findings of the research work which we have done, which are a little more specific. So I will straight go into, and I also will try to take as less time as I can. This was the kind of framing I had done for this session. People would know what is a circular economy, but I thought at least the younger people, if they are there, we could get into that. Then what are the sanitation systems? Because my circular economy focuses on the reuse of biosolids and treated wastewater. And what is the treatment we should be looking at in understanding treatment in terms of the results of the CSC study, which I'll present, and the standards. How do we understand standards, whether they are for use or for disposal, and then what needs to be done as a framework. So I will not spend too much time on this. This is in the slides. It will go to all the participants. This is just a background of what Center for Science and Environment is, because a lot of people were asking me during lunchtime yesterday and day before. So this is just a background of the organization. And this is a kind of work which CSC does, which is in different fields. So I work in the water program, but we also have an air pollution, climate change, industry, food systems, habitat. So there are different programs which are done. And the largest team actually in Center for Science and Environment is our communication team, which produces down to earth and several research publications regularly, State of India's Environment report. So that is the kind of work. And we also have a laboratory, which we have in our campus. So coming to the water program, this is what the water program essentially does. CSE doesn't implement projects, so what we are looking at is more like eyes and ears to the ground, bridging this gap between policy and practice. And looking at policy requirement, it requires that you focus on a long term. You can't work on a year-to-year basis. So we like to work on suggesting what should be done, what should not be done, and how it should be done. That's the kind of focus. And then programs require an understanding of how it should be done. So there, our focus is always on understanding assessments, followed by planning and design interventions. So if we look at the hydrological cycle, this is a slide from Himanshu Kulkarni from Aquadam and his team. We are talking of a circular economy, but there is also a circularity in the hydrological cycle. And the hydrological cycle is not just a cycle of water flows, but is also an underground water flows. This is the focus which Aquadam wanted to show, that there is also something underground, and the water flows are also in different directions in the water cycle. And as we talk of climate change, there is an impact on the hydrological cycle. It gets intensified. So more rain, more runoff, more evaporation. So the cycle which heightens causes the issues which we now have of flooding and drought simultaneously. This is again, it's just an old presentation slides which CDD had done just to explain the concept of a circular economy, which has these two cycles, water cycle and nutrient cycle. And then we have this issue that the cycle breaks down at some time, and the undigested fecal sludge or septage directly gets into the water system and gets into the groundwater. And therefore, it contaminates and it breaks the water cycle. And then we are talking of circular economy, and we need to treat the water. So this is essentially a diagrammatic, I thought it's a good kind of a learning presentation, which we normally do in our training programs to show that once you break the circularity, then you need all these other inputs. Similarly, this is about a sanitation systems. When we talk of sanitation systems, we talk of centralized, decentralized, and on-site sanitation systems. This is also nothing new. Everybody knows about this. The only difference is that Now people are talking of new terminologies, and they're saying that we should not use these terms, but I feel these are very practical terms which should be used. Without using these terms, you can't actually work. So Vishwanath beautifully explained the fact how Bangalore now has a lot of decentralized treatment systems of lower capacity coming outside the town. But traditionally, this was the case. There used to be a centralized area within the town with centralized networks, and then you had decentralized treatment systems all around. So, and these could be of different types, DWATs, water bodies, rejuvenation, and different kind of toilet systems, community, individual. So this was a kind of a map which we also used to explain how sanitation systems have evolved. There's a lot of focus on septage management. And why CSE and we believe it is important is because it represents a paradigm shift from centralized seaward to non-seaward system. So what is being, and I'm not here to defend it, neither am I here to criticize and oppose centralized systems. Vishwanath is here and everybody here knows that whether you go for centralized or decentralized depends upon the density of population and which system serves that population the best. It can be a combination, it can be also centralized. High density populations can best be served with centralized systems, no doubt about that. But this is just because this audience may not know this, I'm just presenting it factually. There are about 1,000 fecal sludge treatment plants which have come up. In Maharashtra itself, I believe it's more than 200 treatment plants which have come up. And similarly, other states, you have these figures for all the states. CSC works in UP, where this is the situation, where about 39 FSTPs called fecal sludge treatment plants, decentralized, have come up. And this is they're spread all over UP. But why we talk about fecal sludge treatment plants is for these 4 reasons. One is that we have now built some infrastructure. If I'm saying Maharashtra has more than 200 fecal sludge treatment plants, we need to actually know what is the status of these plants. So we need to ensure that the plants work. Otherwise, this is going to be a dead investment. And then we also need to ensure that there is some guidance for operation and maintenance, and which is standardized, and so that operations of these treatment systems is affordable. There should be a focus on reuse as much as possible, and we need new standards for reusing the biosolids which are being produced. The reuse of biosolids is also the issue for STPs, and I don't know about Maharashtra, but I think it's everywhere. There are no standards for how we can reuse the treated biosolids, whether it is sewage or septage. So accordingly, that is why we call it a new generation agenda, and that's why we call it as a paradigm shift. These were some of the research work which we did for 3 towns. We published these reports, are available on that website. And the focus, as I said, in terms of paradigm shift is how to make this whole system sustainable. So CSC was focusing on operations and maintenance of these treatment plants, guidelines, bylaws, how to operate them, because these were new infrastructure which wasn't there earlier. In Maharashtra, in my 2 days I spent near Shirdi, visiting 5 towns. I saw most of these FSTPs are within the solid waste management plants. So a part of their operation and maintenance is taken care of by the staff of the SWM plants. But in other states, that's not the case, and this is required. So this is, we also did an assessment of all the 56 towns in UP. So we would like actually Maharashtra and other states also to do an assessment to show what is the status of their treatment plants. So in UP case, we did that to show that we use this so-called an ease of septage management 3-star rating tool, that at least if the plant is functional, every day it receives 20% of its installed capacity as sludge every day for a month, then it gets a 1-star rating. That's the minimum, and then otherwise it doesn't. So we did this. CSC is technology agnostic. We don't follow any prescription of pyrolysis or nature-based systems. We believe nature-based systems are better. So our aim is actually to support and ensure that functionality and sustainability happens. Now I'll come to the standards results. So 2 reports were done in 21 and 22 on the performance of these fecal sludge treatment plants. So the objective of this research was we wanted to see the current use and practices. As I said, this sludge is not being reused. So we wanted to study some treatment plants in different parts of country. We could not get access to Maharashtra, actually. We tried hard. We were denied access. So we did it in about 8 states and 47 treatment plants, which are there in the next slide, to understand what you need data to be able to actually say that this is the parameters of biosolids characterizations which come out of the treatment plant, and then therefore is this within safe limits for reuse or not. So following these objectives, the study was done covering a total of 46 fecal sludge treatment plants, were visited 3 times to collect biosolids from 6 states, sorry, not 8 states. So we also did another study on the liquid part, but I'm not sharing that here. And what we found was that essentially these fecal sludge treatment plants are designed for a liquid-solid separation, and the liquid is treated separately. And the analysis of these biosolids which are coming shows that they are rich in nitrogen and needs reutilization because it has a high organic compound. But the current compost standards may not allow for the reuse, because to reuse it in agriculture, you have to follow the fertilizer control order. So the fertilizer control order here essentially is for organic compost and potassium-rich organic compost. If you see, the differences is not much, and these standards are prescribed, and but there are no separate standards for the sludge which is coming out from either STPs or FSTPs. CSE results on the heavy metal components was this. So except for mercury, most other, out of the 47 treatment plants, most of the other characteristics were within limits. I checked with my lab team and said, why mercury is, 3 out of 46 plants or 44 out of 47 plants don't meet the mercury standard. And I was told that the mercury standard is kept at a very low level. But yet if you employ the US EPA standards, all the treatment plants, those standards are higher. The fact is that there are no standards. So sometimes we rely on the US EPA standards, sometimes we go to the FCO and try to match it with that. The interesting part was that the nitrogen-rich sludge is low on carbon, which is natural because it's human feces and it's not cow dung. So there is this issue of carbon-nitrogen ratio, which CSE pointed out, that currently it's given to be as 20:1 should be the ratio. But that ratio doesn't define the minimum or the maximum, it just gives a ratio. So promoting a circular economy, what needs to be done, we believe that there is also a thing of, are there limits to a circular economy? It's not that you keep producing as much as you want and you keep reusing and there are no implications about that. For example, in Delhi, when the floods came in July this year, the floods were surprising because the amount of water released from the headworks of the dam upstream of Delhi was not as high as the floods in 1979, yet Delhi was flooded. So one of the plausible reasons, which would require, of course, a study, is whether the Yamuna floodplain bed has risen or not. So if the floodplain bed has risen because of siltage in the normal course, that is fine. But has it also risen for the fact that about 1,000 million gallons of day of wastewater is also put in Yamuna? And even if you take a 30 mgd BOD in that, we did a calculation with Dhawal, it was coming to about 110 tons per day of solid waste deposits which are happening in Yamuna. So there is, of course, the other issue of a chicken neck happening in Yamuna as it enters Delhi because the floodplain has been encroached. But if in that chicken neck also there is a rising of the floor of Yamuna, then it is likely to become a perennial problem for Delhi in the years to come. So there is this issue of how much of circular economy you need to see from different aspects. And this is the last slide. After there are 2 slides. So we took out this water sensitive cities index, which we said, let's look at, everybody talks of water sensitive cities, water conservation, but what does it actually mean to have water sensitive cities? So we said cities, normally it is defined in a techno-managerial way that we will do conservation, we will do recharge. But these issues of justice and equity in the reuse and reuse is never stated. And most of the engineering departments also don't use these terms. So who needs water, whether you should give it to industry, whether it should be reused for the, the slums and the unplanned settlements. So this issue of equity and access needs to be, and also as Vishwanath was showing the reuse of who is actually going to benefit from this treated wastewater, even if it goes outside. And therefore we said that instead of looking at projects for water sensitive cities, let's look at these 4 key indicators. One is that you have at least functional infrastructure. Most of the infrastructure in India, whether it is STPs or others, don't work. So functionality, you can't talk of a water sensitive city as if half of your infrastructure is not working. You can't talk of projects of water sensitive cities, lake rejuvenation, conservation, if your major infrastructure is not working. Then the functional infrastructure should be functional as well as inclusive. So it is not just that everything is working functionally, but people who actually need it are not getting. And then there should be a substantial reuse. Again, this is something which applies mostly for the large cities. I don't say that this applies for the small towns. And then managing, addressing the issue of urban flooding. So those are the things which we put as an index for water sensitive cities. And I think these questions we have to answer, are there limits to circular economy, and circular economy for whom? Thank you.
Thank you, Mr. Deepankar Kapoor. You you simplified the circular economy of water with water cycle, hydrological cycle. You focused on fecal sludge treatment plants, which is the necessity of today, and what are the challenges for the maintenance of these plants. So, thank you again. Now I invite next speaker, Mr. Ajit Sawardi. Mr. Ajit Sawardi is the Chartered Civil Engineer, Fellow of IWWA. He has 32 plus years experience of technical responsibilities in water and urban infrastructure engineering in India. He is Senior Vice President, NJS Engineering India Private Limited. Please, Ajit Sawardi.
Yeah, thanks, and good morning. Dignitaries and speakers and committee members, and more importantly, my fellow who are really doing their bit in betterment of water. So your contribution is really important. So it's my pleasure to be in front of you to speak few things about circular economy. Now, circular economy for me is something like, there used to be a story when I was in school that there was an elephant in the room and 4 blind people, and everybody thought elephant is something different. Probably we are talking about this circular economy as an elephant, and maybe crores and crores of people have their own perspective about what circular economy is. Today I'm not really going to sort of touch upon all the aspects of circular economy, but just a take on what I feel is a circular economy. In my presentation today, I'm going to touch upon 3 phases of circular economy. One which I've been following for years, probably even before circular economy was the term was coined. So we have been following circular economy. We may not be aware of that. So I'm going to touch upon that. Then I'm going to touch upon a very interesting development in circular economy, which is an evolving phase. And then lastly, I'm going to sort of touch upon an examples where so far we have been sort of hesitant to say about a thing, but which we have to really follow. So my presentation is a very brief presentation. 15 minutes for circular economy is too less, but still I'll try. Circular economy, again, particularly this term is coined maybe 5 years, 10 years before, and probably it is because of rapid and massive urbanization. That is what we are facing a lot of it. And urbanization speed, nobody would have imagined the kind of urbanization we are facing. Population, industrialization, lot of agriculture, so it's all cycle. And these are all increasing the demand for water. But water is a finite subject. You cannot really produce water. So you have to really use water to the maximum. You cannot create water. The same amount we need to reuse and reuse and reuse. Probably we are talking about single reuse now, but 10 years down the line, we may have multiple reuses. So things are evolving. Circular economy could be a potential answer for this because we have to consider waste as resource and not waste as waste. Because right now we are talking about waste for disposal. Nobody talks about waste as resource utilization. So if we change that mind, if we really see what is a waste and how we can use that as a resource, then only we can sort of see the real value of the waste. Again, the same point coming back that so far we have not been talking about, or civil engineering, water engineering have not adopted to circular economy to the full extent. Probably because we are not valuing our water as precious as maybe oil and gas. Because somebody was giving me an example like the way what oil and gas pipelines are maintained and constructed. Water pipes are the same pipes, but we don't really give that much importance to water because water is not valued. That's a key difference. We need to value water. Resilience and all these things have to be built in, no doubt about it. And climate change, I think some of our speakers also said that climate change is going to make matter more complicated. So we have to be aware of that. What I call it as a CE mantra is 3 R's. We need to really look at 3 R's, is reduce, resource and recovery. So reduce, like as in we say in safety, that avoid, so wherever possible, avoid use of resources if we can. Many times we cannot really avoid use, but say simple case of water. Do you really require water for everything that you do? Because most of the time we waste water rather than using it. Like some time ago, I was working on a World Bank project where they were doing slum sanitation, and there like public toilets. So people used to carry buckets with them and maybe 2 liters of 3 liters of water with them, but still toilets were getting choked. So what they found that people were using maybe half a liter water in the toilet and rest 3 liters to wash their hands and foot. So that's a difference. So wherever water is required, use it or otherwise avoid it. That way we can reduce our consumption. It will sort of change many things. So this is 3 R mantras. This presentation is available to you. You can look at it. Again, as I said, waste has to be a resource. And when we do a circular economy or when we plan water, it has to be from wash basin to river basin. So it has to be basin to basin. We cannot really in isolation think of wash basin and a river basin, because many times people feel that once the water is flown from my wash basin, it's not my responsibility. I do not want to know what happens to that water. But that water through river basin comes back to your wash basin. So this is again a circular economy which we are not identifying. But when we look at it, we have to look at the comprehensive solution of wash basin to river basin. Some of the key examples, and as I said initially, that I'm going to touch upon things that we were doing it before calling it as a circular economy. So my first example is a sewage treatment plant used for Koradi thermal power station, where uh, Nag River, there is a treatment plant of 130 MLD, which I feel still this is the largest reuse treatment plant in India. This was like brainchild of Nitin Gadkari ji, but water from Nagpur was taken, treated, and then taken to a thermal power plant to use as a process water. This was way back when there was no even circular economy was not talked about. Again, like it's only a reuse, but it has sort of helped to reduce the freshwater consumption at that treatment plant. And also we are using power generation through biogas. So it's again multiple uses of the same water. And now Nagpur can sort of treat more water because they are producing much more waste than they were earlier. So 130 MLD of load from Nagpur Corporation has been given to power plant. Now, this plant is running for last maybe 8-10 years, but only Power Ministry has mandated that within 50 kilometers of a plant, if there is a water source, then use it. Similarly, other ministries also can do this mandate, and more reuse can be done. This is really an example of real circular economy. This is a wellspun at Anjar. Anjar is in Kutch, a very water-starved state. And at one point, wellspun, which produces a textile mill, which produces world-class towels, which are used at Wimbledon. So you can imagine the quality they are sort of producing. EU regulations are really very tough, and they are producing those towels which are used for Wimbledon by using recycled water. So imagine the quality of water. But more importantly, this is an example of real economy, that how a recycled water can boost the social economy and real economy of the society, because Wellspun didn't have a water source, and they were at a risk of relocating that plant to some other place where water availability was there. So they had no option either to relocate or treat the water which was available from Anjar and Gandhidham municipalities. So they started taking that water, treated that water, and they are reusing this water to the plant. There is no other source available for them. So entire process, entire factory, entire industry runs on recycled water. And because of Wellspun, then there are downstream industries which came in Gandhidham area, and now there is a big industrial area around Wellspun. So this recycled treatment plant gave rise to complete economy of Gandhidham and Anjar. So I feel you will agree that this is a real case of circular economy. Not only circular economy, but it's a real example of how treated water can boost economy. This is RCF plant, and RCF plant, I think when I started working, this plant was even before that. They are taking raw sewage from Mumbai's Ghatkopar, transport it, treat it, and then use it to their own factory. Now you'll say that what's different? Like there are so many plants nowadays. There are so many like reuse plants, industrial plants, process, cooling, everything. What's so special about it? Probably this is one of the first plants in India where this concept was used. And if I'm correct, BMC was not willing to sell raw sewage to RCF because they were worried about, because it's a subsidized water supply and industrial water rate was much higher. So BMC was thinking that probably we are going to lose our revenue. But still RCF persisted, and now RCF is selling that water to HPCL. So they are even recovering that cost of conveyance and treatment. So this is again a real example, a successful example of how circular economy, two-stage circular economy happens. Now this is the point I'm sort of going to touch upon, because this is evolving sector. So far we are talking only about reuse as either for process water, cooling water, industrial water, gardening, agriculture, horticulture. We are not really talking the full potential of reused water. Because so far we are resisting from using water for potable purpose. There are few examples. I'm not saying that there are not many examples, but this slide indicates a worldwide evolution of direct potable or indirect potable reuse. It has started from 1962. So in US, this first attempt was made in 1962, but still there are very, very few plants in all over the world who are really using this concept of recycling water for potable or a direct potable. It could be like he gave an example, which is again the same thing, like you are using it for indirect potable, but there could be direct potable also. So this is evolving. Since 1962, there are attempts worldwide, but still it has not picked up to the extent that we should have been. There are only few direct potable, particularly in Namibia and South Africa, because these are water-starved countries and they require water from whichever source it is coming from. Hmm? So it is very essential. And I was talking to a few guys who were involved in like South African Day-0. And they are saying that if you really want to avoid Day-0, start planning for at least 10 years. So Bangalore also faced a similar situation that Day-0 was imminent. Fortunately, we could avoid that situation. But from 10 years down the line, what will happen? We have to start planning now. And this is DPR and IPR could be one of the next step changes that we will see in circular economy. Now, when we say potable reuse, there are three scenarios in that. One is de facto. De facto reuse is happening even today in India. Like most of the cities in India use water from river as a source. Now, upstream town releases their discharge into the river. The downstream town picks up the same water as their raw water and then treat it. So this is de facto. We are using this de facto. Nobody bothers about it because it is coming from river. So source is a river, but we are in effect using treated or untreated sewage from upstream city and then treating it further. Interestingly, we worked on a project on Agra, where Agra picks up water from Yamuna, which is Delhi's wastewater. And Delhi is partially treated wastewater. So Agra treatment plant, the first units of Agra water treatment plant are something like a sewage treatment plant. So we are sort of providing treatment for ammonia and ammonia and nitrogen for a water treatment, because Agra is taking water from Delhi and it is full of ammonia and nitrogen. So we have to treat it and then goes as a water treatment plant. So probably future water treatment plants may be sewage treatment plant combined water treatment plants. We need to look at what technology we'll be using. Second is the indirect potable water, where we use it like either filling aquifers, putting in the reservoirs and then again treating it. Singapore is a classic example of new water, which is they put water back into their reservoir and then it supplies back. Third, which is more ambitious, is direct potable. So technology is available today to treat water and to get produce water of required quality, far better than the water we get. And right now also, if you look at like whenever you take say Bisleri water, I request you to look at the description of the treatment they provide. We just look at the Bisleri. But Bisleri, just have a look what they provide. They only say filtration and disinfection. That's it. Only two treatments are given. So if Bisleri can do filtration and disinfection and sell that water which is available for 5 paisa to 20 rupees a liter, so they are adding value. Why we cannot? Because Bisleri takes the same water as municipal water and just treat it. So direct potable water is feasible. Whether acceptability, that's another issue, but we'll come to that. Technologically, it is possible. Now, when we say potable direct, and see, circular economy is all about creating economical value or economy value of that product. So, right now what happens is we discharge treated water into a water body. From that water body, water evaporates and then it goes and then comes back as your like rain cycle, which is always there. But if we just put in some additional treatment and put in an environmental buffer, we can really use that water rather than discharging into a water body and wasting that resource. We can really use it. Hmm? So it is only a matter of additional some kind of a treatment and an environmental buffer. Environmental buffer is essential because we cannot allow inferior quality water because something can go wrong in your treatment plant. So just as a safeguard, we need to put in a environmental buffer. Now, environmental buffer could be like as a technical term, but we use that environmental buffer all the time. Like he is using a aquifer and a filtered well. That is an environmental buffer which acts as a buffer to prevent any contamination passing through. So just by little addition, if we can increase the value of the water, it will be beneficial. Now, why I'm talking about all these? Because Mumbai Corporation has really taken a bold step of starting a pilot plant, direct potable pilot plant at Kulaba. Kulaba is a 37 MLD tertiary treatment plant, already commissioned, running perfectly well. So Mumbai Corporation wants to further take this tertiary treated water and put it in an advanced tertiary treatment plant and produce a water which will be of a potable quality. Now, the current plant, tertiary treatment plant capacity is 30 MLD, but we are only taking 12 MLD of the 30 MLD because this will be a pilot plant. Mumbai Corporation's ultimate plan is to recycle almost 1250 MLD of water, huge quantity, like probably 3 times Nashik. So that scale. So 12 MLD is the pilot plant, but very interestingly, we will be putting in a 0.1 MLD of a prototype plant, which will be trailer mounted. It can be taken anywhere and just put it and plug it and use it. Now, why this 0.1 MLD plant is essential? Because we don't have data. For most of our applications, we don't have data. And this 0.1 MLD plant will help us to acquire data. And data is really essential because people would like to know what kind of process is there, how the water quality is being produced, how consistent it is, what are the parameters, what are the set of parameters that we should be looking at, and whether the treatment plant for 12 MLD is the appropriate treatment or not, or there has to be some minor tweaks that has to be done. So 0.1 MLD plant will run till the 12 MLD plant is getting constructed. So we will have a continuous data of 6 months. And we will run this plant, both the plants, for at least 3 years, if not more. We will get all the data, which can sort of be demonstrated that this can be done. Now this plant will be run on a 15-year by operator. And more complexity because this is an SEZ as well as the land constraint. So it will be a multi-story. So technically it will be a very, very complex project. Now the last is one thing which we are so far avoiding mentioning it, the sludge. Sludge has a really big potential for reuse. And recently IIT Roorkee report says that 90% of the sludge that India produces is of class B sludge, which can be directly used without any problem. Only 10% of the sludge contains heavy metals or other contaminants which cannot be directly applied. So we are talking about 90% of the sludge can be sort of reused without much of a treatment. And just 2 days, last 2 days, I was in a NMCG program where NMCG and we have released a guidance document. It's a consultation process so far, but a guidance document has been released for STP sludges in India, how these can be reused. So this could be the next big stage because so far we are just dumping the sludge. We are not really looking at what the sludge is, where it is going, but we are giving value to water, but we are not really attaching value to sludge. And sludge has a big potential for circular economy. So many, many things that can be done in circular economy, huge things. And I'm sure that in coming years, we will adopt to this very effectively and efficiently. Thanks a lot.
Thank you. Now, next I invite Mr. Abhishek Jadhav. He is from team WS2 ZEPL. Please.
Hello, I am Abhishek Jadhav. A very beautiful morning to everyone. And I'm very thankful for the dignitaries and IWWA and water professional that I'm sharing such a beautiful stage with all of them. So, starting with the presentation, this is about the packaged water treatment plants, which I'll be presenting on behalf of Mr. Shirish Kardile, K Consultation and Water and Sewage. So this packaged water treatment plants are being manufactured here in Nashik, in Sinnar MIDC, for a ranging capacity of 0.5 MLD to 3 MLD. So these are the schematics of what the prefabricated package treatment plant includes with. It has a basics units of sealing chamber, mechanical flocculator, the tube settling tank, rapids and gravity filters, and pump water sump water house. So the receiving chamber here is designed to receive the raw water, which has a V notch, which should measure the flow, and it dampens the turbulence. And on the downstream side, the coagulants are added. The further this water is added into the flocculation zone, which has a mechanical flocculator with an agitators, with 4 to 7 RPM of rotating pedals. This has multiple recontacts, which allows the turbidity to settle down in the hopper below. This water further goes through the flock distributor pipes in the upward direction through tube modules in 60-degree angle inclined, which gives the surface to the flock to settle down, and further also can be collected down the hopper. Cleared water goes up in the collection troughs, which are hot dip galvanized, and further introduced into the rapids and gravity filter for further polishing of the turbidity. The dosing further for the disinfection of water is done by bleaching powder. So this is what the plant consists of, as I already explained in the previous slide. So these are the process descriptions, which was further explained in the schematics. The only mechanical equipment which is a part of maintenance, which usually occurs in the treatment plant, is the mechanical flocculator, and it is the only equipment and only essential one. So this is a typical 3 MLD plant, which was earlier installed like 5 years back in Nanded region. This is nothing but 2 streams of 1.5 MLD, sealing chambers followed by mechanical flocculators, the tube settlers, and rapids and filters with alum dosing arrangements. These are few photographs being carried out in Jal Jeevan Mission. This is a whole scheme which has ESR, the sump house, and the 0.5 MLD compact treatment plant. That's a 0.8 MLD. This is a 1 MLD treatment plant at Ahmednagar region. This is a 1.5 MLD Rajapur Ahmednagar region. How compact and modular it looks around the sump house. This is a 2 MLD plant in Nanded region. And the beauty of this product is in mountainous high terrain regions, we actually modify it accordingly. And this is actually in Chiploon. The plant is sitting on the top of mountain on a hill rock. This is how it is transported on low bed trailer, stacked up on the low bed trailers, and can be carried out across the country. The erection at site. The whole erection process hardly takes 5 to 7 days at the site. The minimum space requirements. Starting with 0.5 MLD, it only requires 100 square meters of area, while the maximum, that is 3 MLD capacity, requires 400 square meters of area. So going with the silent features, construction of small plants in RCC is cumbersome as there is shortage of labor, the availability of land. So hence, prefabricated ready-to-erect plants is an attractive and alternative option for speedy execution of water supply schemes. Standardized modular treatment plants designed with highest efficiency, hence transportation and delivery. All the processes in the treatment plants are as per the CPHO manual, small and simple. It is robust, portable container tank material, which is of 6 MS thick plate on the outer and 6 FRP lining on the interior. So the water doesn't have a contact with the MS sheet, hence there is no corrosion occurring. Requires minimum space. It is shop manufactured, hence the quality is assured. It's a cost-effective, quality treated as per CPHO norms, and anti-corrosive treatment with glass fiber reinforcement lining on the inside of the tank. Plug and play at site, and hence short time downtime for erection. WS2EPL has already installed and commissioned around 50 treatment plants under the government schemes, peri-urban schemes, under Mukhyamantri Rural Drinking Program, then Metropolitan Region Development Authority, Nagar Panchayat, and currently is working on a Jal Jeevan mission. I have a short video that should support my presentation. So this has from manufacturing to the erection to the site delivery, and then commissioning whole scheme has been played. This is how the plants are been transported through low bed trailers. All it needs is the civil work, the foundation, and the plant is ready to go. It is just installed on site and plugged up. This is a 1.5 MLD capacity treatment plant. The raw water source, jackpel from where the water has been pumped to the treatment plant. This village has a balancing reservoir capacity with a 3 months holding capacity in dry times. starting with a stilling chamber, the raw water inlet, the flocculation zone, the tube settlers with collection troughs, hot dip galvanized, hence no rusting. And further, the water is taken into the rapid sand filters. The compact design around the samples. So that will be it. The backwashing arrangement can be done either in the pump house with backwashing pumps, or if the elevated storage reservoir available for the rapid sand filters. So that was package treatment plant from WSTPL. Thank you.
Okay, thank you. Now, I invite Mr. Sagar Patil. He is Senior Technical Officer, All India Institute of Local Self-Government and Regional Center for Urban Environmental Studies, RCUS. Please limit your presentation in 10 minutes, right?
Thank you. Thank you for the opportunity, IWWA. I'm Sagar Patil. I'm representing I will be talking about optimum utilization, opportunities in optimum utilization of existing fecal sludge treatment plants and urban used water management facilities. I'm representing Regional Center for Urban and Environmental Studies, established by Ministry of Housing and Urban Affairs, Government of India, at All India Institute of Local Self-Government. We have pan-India reach. We work closely with local to central government in WASH sector. The coalition Maharashtra Urban WASH Environmental Studies Coalition was a joint initiative by RCUS, AILH of Mumbai and UNICEF Maharashtra. We work closely with, collaboratively with as many stakeholders in the sector of water, sanitation and hygiene. Extending our partnerships with government, we have signed MOUs with Urban Development Department, Government of Maharashtra under Swachh Maharashtra Mission Urban, and Department of Environmental Engineering and Climate Change under Maji Vasundhara Abhiyan, famously known as My Earth Mission. Diving into the topic about, we need to understand what was the approach of India before launching of the first stages of SBM and Amrut. Previously, our focus was on conventional sewer sanitation systems with respect to implementation of sanitation infrastructure. Last decade, when first stages of urban Amrut and SBM launched, our focus has shifted to mix of conventional sewer sanitation system to non-sewer and plus non-sewer sanitation systems. With the result of that, India have developed around more than 500 FSTPs, little bit older data. Currently, I think it's around 1,000 FSTPs, and 1,400 STPs were already there with larger cities. Strengthening this to achieve SDG 6, India have also launched second stage of Amrut 2 and SBM 2, Clean India Mission 2. where India is focusing on covering all of the 4,700 plus ULBs to achieve this, to ensure the sustainable sanitation for all. Billions of investments is already, budget is already allocated to the, in the sector, and India is marching towards achieving this goal. Already we are seeing lots of cities are transforming themselves from ODF to ODF++, where they have to manage their all kind of liquid waste along with fecal sludge and solid waste also. Coming to the Maharashtra, which is largest economy of the country and also leading in development of sanitation infrastructure, we have around 22 FSTPs and around 150 STPs in the state. And under Amrut 2 and SBM 2, India, Maharashtra is also working towards achieving this goal in both sewer sanitation system and non-sewer sanitation system, focusing on both of these approaches. Considering this huge investment going into the sector, going into this field, and we are seeing lots of challenges in this upcoming infrastructure. Like land availability is one of the major issues, and also covering, we have seen the profile of the our towns, where central part is covered with the sewer network and periphery outer part is always dependent upon the non-sewer sanitation infrastructure. So these are the challenges of this challenges in front of this upcoming infrastructure, where existing infrastructure also have some of the challenges and opportunities to improve their utilization rate and improve their treatment efficiency. So to bridge this gap, our Maharashtra Mahawash Coalition have completed 5 projects last year. We will see 2 case studies in detail. First one is Indapur FSSM model, which focuses on urban-rural convergence and refurbishment of the FSTP. To understand the project, we need to understand the status of FSSM in Maharashtra, where urban Maharashtra is already marching towards attaining the ODF plus status and implemented more than 200 FSTPs. But still, these existing FSTPs has 3 challenges. First one is irregular and insufficient incoming fecal sludge load. Second one is design limitations, and third one is O&M cost recovery. So that on these 3 parts, ULBs were struggling. When we have interacted with the ULBs, we have received this feedback from them. And at the same time, the rural Maharashtra is far away from any treatment facility, and there was no treatment facility for FSSM service delivery. So to mitigate these challenges, there could be many solutions or approaches. We thought that we can bridge this gap, or we can have this solution which will solve these issues. So with the urban-rural convergence and refurbishment of the FSTP. So and at the same time, government of India also directed through various circulars to have this urban-rural kind of convergence to increase or to maximize the optimum utilization of the existing infrastructure in the FSSM. So Indapur is a town in Pune district. We brought together all the Indapur Municipal Corporation, the ULB, and surrounding 16 villages on same table. After series of consultations and IEC activities, we have Indapur Municipal Corporation agreed to treat fecal sludge from the rural area at their FSTP infrastructure. To see the exact how the FSTP was and how we have refurbished it, this is the model FSTP FSTPs in India, representing more than 200 FSTPs in the Maharashtra. Sorry. There are 3 major treatment units, starting with the unplanted drying bed, where sludge dewatering happens, and the liquid percolates down and taken to the liquid treatment unit, where ABR, AF, and PGF, these are the 2 treatment units where liquid is being treated, and the retained sludge on the filter media is taken out for the reuse. There are some design limitations. When we have interacted with ULB and also reviewed many of the FSTPs at various ULBs, we have observed those, and we try to bridge this gap and try to solve these issues by refurbishment of this FSTP. The 10 KLD of FSTP at Indapur was refurbished, and these blue highlighted units were added. like receiving fecal sludge receiving station with screen chamber and settling thickening tank. With this settling thickening tank, the sludge which is already digested is more, its sludge dewatering capacity is enhanced, and so that our drying time is also reduced. And at the end, we have added tertiary treatment with filtration and disinfection. Because of that, we could achieve NGT standards of the discharge of the treated water and biosolids. Highlights of these projects where we have adopted hybrid approach. The low operation maintenance cost of the nature-based solutions, and along with electromechanical component addition. So we have achieved good efficiency of the electromechanical treatment components, and with lower operation and maintenance cost like NBS, natural systems. The treated water we are reusing into the land applications, and biosolids we are co-composting with existing wet waste composting unit, which is in the same premises. The breakdown about the revenue and expenses of the FSTP. The FSTP operation O&M cost is 30,000 rupees, and 38,000 per month was for the desludging vehicle. We could achieve the break-even only after this urban-rural convergence. Still, we have not achieved it, but we are at that pace where we will achieve it in upcoming days. These are the standards, NGT norms 2019 notification. With this treated water and biosolids, we are able to treat our treated outputs with the standards. These are the photographs before and after intervention. Appreciation received from the local government to the state government officials. Latest photographs of the FSTP. Our next intervention is at Sangli Mahanagarpalika, where we have added a component of scientific co-treatment of fecal sludge at STP, existing STP. Sangli is a town of around 5 lakh population, which the sewer network of the city is around 60 to 70%, and it has a 23.5 MLD STP with SBR technology. This utilization rate was consistent at this 50% rate, and for the FSSM service delivery before our intervention, Sangli was dependent upon Sangli has a 10 desludging services vehicle. They used to empty the septic tanks from the non-sewered area, which is covering around 25 to 30% population of the city. And the desludging demand was around 6 to 10 trips per day, which is around 20 KLD capacity. The main factor to notice here is they used to empty the septic tanks and discharge their fecal sludge at the last pumping station, in the machine hole of that pumping station. The problem with that practice was that pumping station was under flood-prone area. Sangli is vulnerable to the floods, and because of that, this flood-prone area's location, this sewer networks they used to clog. There used to clogging and blockages in the sewer network because of high consistency sludge dumping into that, and also because of that, waterborne disease also used to spread in during monsoon monsoon time. And at the same time, the STP was at underutilized capacity. So all of these factors led us to have this intervention where we have added this co-treatment infrastructure. We have added 4 treatment units, starting with screen chamber, high rate digester, settling and thickening tank, and equalization tank. The capacity of this co-treatment unit at existing STP is 50 KLD. Out of that 50 KLD in the settling thickening tank treatment unit, around 10 to 15 KLD sludge is being settled down and is taken to the centrifuge unit, which is existing at the STP. And around 35 to 40 KLD supernatant liquid is overflows to the equalization tank, and from that it is connected to the inlet of the STP. And after this, all the treatment operational processes happens normally at the typical sequential batch reactor technology at the existing STP. Looking at the finance, this entire intervention costed us around 30 lakh rupees capital cost, and operational cost is around 20,000 rupees. Main advantage of this, if Sangli had decided to go with the standalone FST, because the 20-30% of population which is dependent upon the non-civil sanitation system, if they had decided to go with the standalone FSTP, they could have costed around 1 crore rupees. They have saved that money, and around on this intervention, around 1.5 lakh population is dependent. And apart from that, also the utilization rate with respect to the organic load in the STP is also taken care, is also increased, and a reduction in this clogging issues also now reduced. These are the photographs of the intervention. Appreciation from the commissioner and the health inspector from the Sangli Municipal Corporation. This is the overall impact of our 5 projects that we have implemented. Other 2 projects are with respect to grey water and nala treatment. You will find all details on our websites. To conclude this, one policy level change that we could bring. Currently, just Maharashtra has developed its rural FSM plan, where FSSM is being now implemented in rural area of the Maharashtra also, and they already taken up this. After this successful implementation of our intervention at Indapur, they have taken up this and directed ULBs to promote urban-rural linkages. And already 28 MOUs have been signed, and 52 more clusters are in process to sign the MOUs. Apart from urban-rural convergence, there is a very good opportunity in rural-urban convergence also, where the implementation of the infrastructure will be in the rural premises, and urban waste will be treated there. And at the same time, considering this co-treatment also, in co-treatment or at the STP, there is also urban-rural convergence. There is also opportunity in urban-rural convergence, and additional revenue for the ULBs by this rural demand or the urban demand is also possible. So, circularity and policy level and administrative, there are many benefits and win-win situation for both urban and rural areas. Thank you. You can scan through our websites for the partnership, and thank you for the time.
Thank you, Mr. Patil. So, at last but not least, Engineer V.K. Sawant, Chairman, IWWA Center, is welcome for his presentation.
Good morning, friends. I am the last. Always bowler is always the last batsman. So, today's my presentation is nothing regarding the technology, because you all are a technology expert. I am not going to add in that. But before that, let me state my background so you will understand why I chose this presentation. I work as an executive engineer in Goa, handling the water supply of the 3/4 of Goa, wastewater treatment 3/4 of Goa. At a young age, I decided to jump other side of the table. So one of my portfolio was utility in the private sector. So I have seen both sides of the table. So what are my experiences? Just I want to share. When we talk since morning, since yesterday, and number of times we always talk sustainability of the water supply network. Now this sustainability of water supply network is just like an elephant described by the different blinds. I am one of that. So finally, sustainability of what? Is it a sustainability of the water, or whether the sustainability of the consumer, or whether it is the sustainability of the utility? I take it as a sustainability of utility. Because unless and until utility sustains, whether it is a government or private, it will not deliver the good. I think you agree with this. And their sustainability comes from where? Some income, either subsidized or direct income of sale. So that's the angle I want to tinkle with it. So I'll start my presentation. You must have heard this a number of times, SDG goal, and we have to do by 2020, 2030, 2040. So everybody should get water, and that water should be tap to mouth. Okay? I don't want to read it because you are already aware of it. Then somebody, activist, goes in the court, he says it is a fundamental right. It is already enshrined in the Constitution. Yes, everybody knows that. Now, we are talking about the water, whether total quantity of water is increasing. I don't think since Earth was born, what I say, that water is the total quantity of water is the same. Sometimes we may be drinking peas of the dinosaurs treated by the natural environment. But it is already projected by 2030, our demand will be double the availability. In short term, if you say that the entire water in the world is a 220 liter barrel, what the water we can use is hardly a teaspoon. So this is a 5 ml quantity. So that is the quantity what we are going to use it. Now see the picture, global warming. You must have seen these pictures, China 2017 and now August 2022. This is a picture. Again China, just see how everything is getting dried up. You must have heard about the Cape Town, you must have heard about the California. Way back in India, Chennai, you see the pictures, 2018, 19 and 19, same one. So yes, there is a problem. If you look at the table, average, we are already stressed. And somewhere 2061 will go in scare. So this is the condition what we talk of the product, raw material. Now this product is naturally available. So we are processing and we are supplying. Now if you look at total investment, what we need, that power sector 14.7 trillion, then transport 8.4 trillion, investment telecommunication 2.3 trillion, but water and sanitation cost about 800 billion. And there is a shortfall of $114 billion. This is not my figure, it has published somewhere. Now India needs 333 billion from 2016 to 2040. Whereas we could pump 2019 to 2025 investment about 94 billion only. From where this money is come then? See, without money, neither government sector, neither private sector can achieve this target. So how it will come? So it's my experience, I thought that somewhere our thinking of this entire process is fundamentally wrong. Supplying water is a service or it is a commodity? Now, this is a basic question I'm asking. whether we are carrying out a humanitarian service or we are selling the product. You know that commodity, you very well know that commodity naturally available, we can be sold in the market, gold, rice, cereals, etc. And service, you know that education, health, etc. Or some product manufactured and sold. Now, in India, you see the service, yes, we provide the service. Where there is no water, we provide by tanker. Abroad, yes, they also provide the service. There are public taps are there, fountains are there. Now, USA it has started, it is treated as a commodity. There is a commodity market. It is definitely they are trading as a commodity. But this confusion, whether it is a service or commodity, is still lies. And this is the main root cause. See, if you treat as a commodity, is a product, can you close down your treatment plant? There is no water. Or can you short up the price? Today my price is 100 rupees kiloliter. Can you do it? Not possible. Suppose it is a service. In COVID such situation, what happens? Airports were closed, institutions closed. Can we do that? So water supply cannot be stopped, the service cannot be stopped. So we were somewhere a different entity. Somewhere different entity. And what is called, we are selling essential product. Just like what antibiotics. These are the life-saving products we are selling. Now, question comes here. Everybody wants, this is the thing, smart water. Safe, measurable, affordable, responsive, technical based, tech-based water solution. This is you must have heard this term number of times. But can you achieve this term with what are the facilities, income, what are the money we have? Impossible. It is just like asking a footballer to kick a penalty corner where his legs are tied, and goalkeeper, instead of blocking the ball, he will go on shifting the goal. And that is precisely happening with the utilities. See, I'll tell you a simple example. Earlier, water treatment effluent standards allowed 100 BOD for irrigation. Then 40 was permissible where water is released in the inland sources. Then it was made 20. Then it was made 5. So any utility design works out the entire economics on 140, and you change the goal and you say they should be sustainable. Will it be possible? Now, I'm coming down to the price. Now, we talk of the tariff or price. A general definition, what is the price? What is the cost of raw water plus cost of processing cost and plus deliverance cost? Is it like that? It is not like that. It is the price of water, it's the price or cost of not having water. That's the point one should understand. Now I'm giving a simple example in Goa. This is a real example in Goa. If you see, we supply the pipe water from 0. We supply some at free of cost also, to up to 50 maximum slab. a tanker water for different colonies, raw water, is supplied by private entrepreneur at the rate of 100 rupees per kiloliter. Our water doesn't need a treatment, but their water, you need a treatment. So consumer has to take it at the rate of 125 to 150 rupees per kiloliter. Whereas majority of we supply 0 to 10 maximum. So can you compare this? So cost of water should have been, tariff should have been based of not having the water. What you have to incur the cost. If there was no pipe water, how much money you would have invested to get that water? Then that should have been reasonability. Now you check it the packaged water. Packaged water we are buying at the rate of 2,500 per care. And then treatment cost, we are taking hardly 25% amount as a treatment amount for the wastewater, which is again about 5 rupees, 4 rupees, again 2 rupees. Actual treatment cost for the private colonies, it is coming running cost more than 40 rupees per kiloliter. So this is the vast difference. So that a principle for fixing the tariff should not be what should be the cost of water for processing, but what is the price for not having the pipe water or not having the treated water. This is one fundamental thing we should understand. Now, everybody knows that everybody wants 24/7 water, and that is also subsidized cost. Then, yes, we say that some poor fellows, they cannot get water, they cannot survive, this is service. Okay. But we forget there are some fellows have swim in their swimming pool on top floor. You are supplying water at the same rate for the domestic. Now, if you look at this table, that nobody understands, consumer, and that is a consumer or in the common public, they are forgetting they are buying water which is invisible water, and they are buying at a market cost. See, any person who is staying in Jhopatpatti, he is not using TV, he is not using mobile to generate that data, towers are there. To generate that power, you need a water, that industry is purchasing at the rate of 100 rupees. And if there is no pipe water, they may be purchasing 200 rupees, 300 rupees. So they are already buying invisible water at a market rate. Look at this one, a t-shirt. To manufacture the t-shirt, how much water you need? And work out that proportionately. There may be some differences. I don't say I am 100% accurate on this, but there has to be. You see that we are using almost about 3.5 KLD water per capita, indirect water, and we are paying at a market rate. We are paying at a market rate. We don't see, we go to McDonald's, you take a burger, we pay 250 rupees, 350 rupees, we don't bargain on that, we don't grumble on that. So, and that 300 rupees contain the cost of water to produce that burger. So, in short, we almost pay 3 kiloliter of water per day at a market price, but we haggle over to supply 180 liter maximum capacity per capita water day at an affordable rate. So simply, we buy visible pipe water. We want visible pipe water at a subsidized rate, and invisible water we happily buy at market rate. So this is the dual pricing. It's creating a disparity. Sustainability, see, no organization can survive unless and until there is a money coming out of it. Now what happens? There is a less finance per OMN. Yes, in government sector also it happens. We install the plant, we install SCADA. When the maintenance grant is not there, SCADA becomes redundant. Then upgradation. You won't believe, we are using the infrastructure we have created 30 years, 40 years back. To upgrade that infrastructure, you need a money. Then it happens what? 40%, 50% NRW. Then, if there is no value, nobody is accountable for the losses. And the moment, this I am speaking private as well as a government sector, and if there is a loss-making unit is there, finally, best brains are not attracted to that sector. That is another aspect. Now public what happens? That is a poor reliability. It is short supply at a chosen hour by the utility. Trust deficiency about the quality of water. There is definitely a trust deficiency is there, because I know that last time in Goa, in the meeting, we have seen, then we started talking, then a minister was there. I asked the minister, sir, we are treating the water, we are supplying the water. Look at our table. There is a mineral water. If I am manufacturing a Coca-Cola, I will not keep a Pepsi on my table, I say. That day onwards, we started using a tap water. Like this COM meeting you must have seen, we have used all tap water. So, we ourselves should build a confidence in our product so that we can be able to sell it. That is the thing. Then, can consumer ask the compensation for non-supply? Because I know that as executive, I issue the notification, 2 days, this is a breakdown, no power shutdown, 2 days you will not get water. So there is no class actions 2 times costing you. So what happens? What consumer do? Consumer start storing the water, or consumer start retreating the water and end up in spending more money than what we are spending per kiloliter. That is, ultimately it happens. So somewhere it has to be stopped, and that was our goal. And then, finally, our total water is the same. So we'll end up with a more polluted water than which is potable water. Now, if situation continue like this one, it will happen, finally it will come to a bankruptcy. So somewhere we have to think about the pricing, tariff. So why we should not declare? It is not a service, it is an essential product. You have to supply, no doubt. And utility is a vendor delivering the product at your doorstep. That is a market obligation, contractual obligation. But consumer has to pay right price for the water. Then there will be win-win situation for consumer as well as utility. See, in Goa, we did one, sometimes we do a lot of experiment. So we did one experiment, I'm telling you. We decided to supply water 16 cubic meters, 16 kiloliter per month for domestic connection where the meters are working. We have got 100% meters where meters are working free of cost. So everybody jumped on us. They said, you are saying that you are in loss and you are giving free of cost. 16 cubic meters.
Sir, kindly brief.
Yeah, 2 minutes. It is ending. So, finally what has happened, that because of telescopic project tariff, our revenue increased by 50%. After supplying free of water. See, this is the way we should work. So we should work as a product. Any company want to market the product has to decide. We are in a confusion, service or commodity, and then the entire thing gets confused. Thank you very much.
Thank you very much, sir. You have given a very good idea regarding the water pricing. So, I invite questions from the learned speakers. If there is any question, kindly present your question, if there is any. Yeah.
Good morning. My question is to all the speakers. It's a general question. Have you come across any treatment plant where the treated effluent has the standards as per NGT, so that we will visit that plant in Maharashtra?
In Maharashtra. Have you any? But I gave you reply. I do not aware of Maharashtra, but in UP, Uttar Pradesh, there are many plants whose effluent complies with the standards of the NGT. Any more question?
Sir, I am Adil Mohan from Odisha. I am asking this compact treatment plant, raw water, what is the maximum raw water that can be treated? Turbidity.
Any?
Maximum raw water turbidity.
So the maximum raw water turbidity we can treat is up to 300 NTUs. 200 to 300.
300 NTU.
Yeah.
But you are showing this water is more than 300, I think.
Yeah, in case of if there is a silt or silt is coming from the rivers, so we can also add the ballasting settling tank and further of stilling chamber. In that case, if the turbidity extends.
So now I am. Sahuji, last question.
It is related to Mr. Kadile. Have you compared the cost of your this model with the RCC treatment plant and the life of your this compact plant? We consider the life of our RCC plant for 100 years. In design, we design for 30 years, but as per norm of RCC, it can serve more than that. 30 years we take design period, and we augment after 15 years. Because of the planning pattern, 15 years it is designed for 15 years, then again augmentation. But this plant is continued. So what is the life of your compact plant?
So going with the life of our treatment plant, we are designing it for a period of 30 years. And the only mechanical component here is the mechanical agitator assembly, which can be replaced further if needed. And regarding the cost comparison, I'm sure Mr. Kadile can answer it better than me. I'm just.
Okay.
Only just I give only 2 sentences as a closing remarks. Wastewater should not be considered as waste, but it should be considered a resource, and it should not be the burden to the government or society. It should be treated as a opportunity to get some new product. That is the whole idea of this session, and this session was very successful, and I thank all the learned speakers for their views. Thank you.
Thank you, Gupta sir, for chairing the session. Now I request Dr. Rajesh Gupta sir to come here and facilitate the chairman of this particular session. So you can discuss during the tea break. Thank you, sir. Now I request Mr. Gajbia sir to come here to felicitate the speakers of this session. Mr. Vishwanathan, yes. Yeah. Mr. Dipender Kapoor. Mr. Saudi ji from NJS Engineers India Private Limited. Mr. Jadhav from K Consultation. And our own Sri V.K. Sawant sir. Thank you, sir. Now there is 15 minutes tea break, and then again we will gather for the next session. Thank you. Yeah.
Yeah, I'm from All India Institute of Local Self-Government. Just our Sagar Patil presented PPT with reference to FSTP refurbishment. I think because of the time constraint, he had just missed very, very important point, and that is our technical partners for refurbishment of FSTP was ESF, and it's a great thing that ESF, and especially I will mention Mr. Dayananda Panse, ESF helped us in refurbishment of this FSTP, and they were our technical partner in this project. This was the very important point that
Thank you, thank you. Thank you, madam.
Thank you, thanks a lot.
We will take one photograph. Please come in. Sir, आगे आइए. We will take one photograph. Here, sir. Please. Panse, sir. Dr. Renu Vyas, Professor and Head of Institute, MIT School of Bioengineering, Engineering Science and Research. Dr. Prasanna Jogdev, South Asia Operation Manager, IWWA, Chennai. Dr. Dineshwar Prasad Singh ji, our engineer, past president, IWWA. Dr. Pawan Lapshetwar, Chief Scientist and Head, Water Technology and Management Division, CSRI Neri, Nagpur. I request Chair to start the session.
So I welcome everyone for this fifth session on the theme climate change adaptation and resilience. And in this session that we have the five presentations, one which is shifted from the sixth session here, Mr. Arjun Ahmed Jahari is going to start, and then we have four more presentations. And the total time which is available is around 1 hour for this session. So I request every presenter to complete his presentation within 10 minutes time. So we have some time left for at the end for some discussion. And I think considering this, that organizers have now put 2 chairmen here, so to manage this time. So the time can be managed properly, and my request to all the presenters. So I request Mr. Azwan Ahmed to start his presentation.
Thank you very much, Mr. Chairman. Very good day to all the delegates, fellow speakers. Thank you so much for the opportunity to be here. As always, it has been a great 1.5 day here in Nashik. For us from IWWA Consortium, we had a splendid time here. We had a lot of lessons learned from all of the other speakers. I think it's a kind of session that I personally feel that 2 days is not enough, but we are here to make full use of it, and then here I am trying to contribute towards the forum, towards the conference, contributing a continuity from what was shared by my chief executive yesterday, Mr. Narendra Maniam, who shared about the general overview of IWWA and what we do to achieve the financial sustainability, operational sustainability, as well as environmental sustainability. And today I will just zoom in to one particular topic, which is on tariff management and the case study of IWWA on how we will manage to get our tariff revised after 28 years, right? And since, quoting the Mr. Chairman just now, that we have double chairman today to make sure that it's within 10 minutes, so I'll better go straight to my presentation right now, right? Okay. All right, and I think this has been covered by my colleague, my chief executive yesterday, but I just like to highlight one thing, that IWWA operate in a highly regulated environment. That means that a lot of regulatory being enforced to us, and just like any other utilities in all the other parts of the world, that we cannot simply revise our tariff. And we have been trying to do that for the last 28 years, and only recently that we were able to manage to get it. And referring to this particular slide, as you can see that we are part of the Ministry of Natural Resources, Environment and Climate Change, and the party that is responsible for any tariff revision, not only for us, but for all the water operators in Malaysia, would be the National Water Services Commission, or SPAN in short. And while SPAN is the regulator that is in charge to work with us in proposing any tariff revision to the water industry, but the decision goes all the way until the cabinet. That means that our minister himself will be the one bringing it in front to the cabinet ministry, to the cabinet for the paper to be presented, and eventually the decision is being made by the cabinet chaired by none other than the Prime Minister himself. So it's a very long process, it's a very tedious process, but as mentioned by my CEO yesterday, that if the business plan is a set of jigsaw puzzle, the largest piece of this jigsaw puzzle is the tariff revision, because it's so meaningful in terms of ensuring financial sustainability, and it unlocks a lot of potential in terms of sustainability for the company. Right? And this is very important because the nature of our operation. We operate more than 7,000 sewage treatment plants and over 21,000 kilometers. And whatever that we earn or whatever we can get through our income not only goes to the operational cost recovery of our plants, but to also future-proof our operation. That means the investment in terms of technology, investment in terms of research and development, because this is so important. As we can see for the last 1.5 days, a lot of things, innovation need to be hand in hand in terms of our operation of utilities, including in the water. That means that we need to invest on Internet of Things, we need to invest on digitalization. So all this would require funding, and that strengthened the case in terms of the importance of a competitive tariff revision for utilities like us. Right? And sorry, these are some of the challenges that we have been facing for the last 28 to 29 years. One thing being the uneconomical sewerage tariff rate. So as I mentioned earlier, that we have not revised our tariff rate until last year. So that's 28 years of having the same tariff. And despite the tariffs remains the same, our other costs have been increasing. Naturally, we look at electricity, for example, our biggest cost contributor. Electricity has increased more than 3 times over the last 28 years. And this has put an additional pressure to us. And yes, we have embarked on various operational improvement, various lean management approach in terms of updating and upgrading our practice as well as our technology to ensure that we are more lean and cost sensitive. However, there's a limit to how much that we can do that. And eventually we are at the stage that we need that tariff. Hence, we brought the case through a proposal to the government. And at the same time, all this while we have been depending on the government subsidy. While it is quite normal for the government to subsidize such a strategic asset or strategic operation like storage operation. But we felt that at the end of the day, being a government-owned company, we act like any other private company. We need to take care of our P&L. We need to take care in terms of being able to financially sustain with our own tariff and our non-core business. And with that kind of approach, we believe that despite the government has pumped in quite hundreds and hundreds of millions of subsidy every year, we felt that the same amount of subsidy could be used for other needs, highways, hospitals, and so on. So we felt that there's a very good model that we can sustain on our own, and based on that, we have submitted the proposal to the government. And basically, this slide covers the IWK's tariff revision journey, and this is what we have gone through for almost 1.5 years, close to 2 years, the process that we took. As a team, it is a cross-functional approach where it involves multiple departments within IWK as well as our stakeholders, including the National Water Services Commission. And if you can see the first 2 boxes, which is the proposal development and stakeholders engagement, this is what we believe is the strength of our approach, where we took up the proposal and stakeholders engagement together in a way that in previous years there was attempt for us to submit proposal, but it's more from the perspective of IWK as a company. But this time what we did was the proposal was all inclusive. We had multiple engagements throughout the process at the very beginning with government ministries as well as the regulator, as well as a lot of consumer groups and research institute, because we want to make sure that what we do, what we are proposing is something that beneficial to us, but also not burdening the people of Malaysians. Because we know at the end of the day, there are a lot of other things that people have to pay, the bills that they have to pay every month, but we want to make sure that the increase is very much minimum, yet at the same time is significant for us. So finding that right model or right price point that benefits the consumers as well as us would require a bit of engagement, and we did that with a lot of research institute and consumer groups, as well as engagement with public. And that helps a lot, because when we submitted the proposal, we have some sort of like an endorsement from these parties, so it's not like something that we only believe that is the right price point, but supported by the engagements that we have had with all these consumer groups. And we went through the cabinet approval, it got approved, and then right after that is a challenge in terms of operationalizing it, putting into the system in making sure that our systems are ready with all these latest tariff and latest numbers, as well as the implementation in terms of the communication, letting the public knows that the tariff will be revised or has been revised and will be implemented after 28 years. So it has been quite a positive experience. I'm just going to flash through some of the lessons learned that we had through this exercise. I think, as I mentioned earlier, that these are the strategy that we took, proactive and constructive engagement, seeking the buy-in from stakeholders and consumer groups from the very beginning. Phase storage tariff revision, that means that instead of we going through a price point that is almost close to cost recovery, we started off with saying that, look, instead of we have a one-time tariff increment, let's phase it out to a 6 years period. And that has helped to get a lot of buy-ins from various parties. And we also introduced what we call a sewerage rebate. That means that for a certain group of consumers or customers, they will not be impacted by this tariff revision. Because we know that with COVID-19, the coronavirus pandemic just ended, we know that a lot of people are still trying to recover. So we knew that there's a certain group of people that we will help, so they will still pay the same amount of money. And all this is being communicated through a holistic communication program that we have charted pre and post. Thank you, sir. And this is the breakdown that we've had over the 4 phases. And as I mentioned, this will be the rebate program that we have introduced. The lesson learned from this is that don't recreate the system, use whatever we have. So in Malaysia's context, we have what we call this e-Kasih, which is actually a government initiated program that has a database of all the people in a poverty data bank. So we use this database and it's much easier for us. In terms of lessons learned from benchmarking, these are some of the strategy that we use. We benchmark ourselves against some of the other utilities out there versus water utilities. Why this is important? Because it's built up a good narratives so that we were able to connect to the people as well as the government. And not only that we compare with other utilities, we also compare with all the normal items that they use on a day-to-day basis. And a lot of people were responding to this saying that, look, if you can afford to pay Netflix or you can pay your internet or telco, you also can afford to pay your storage charges. And all these we've put together into a comprehensive communication plan. We do use our 3,500 staff as an internal ambassadors. So when they go back, they talk to their relatives, they talk to their neighbors, so that the messages is spread. We also work with elected representatives because this is a very political sensitive issue. And we are lucky and we are thankful that we have support from the politicians as well on this, based on a lot of engagements that we have had. And last but not least, these are some of the examples of our communications that we did. It's a very layman term. We touch both traditional as well as social media. And these are some of the feedbacks. Despite all the preparedness that we had, we do get some constructive feedback. But I think that's the beauty of the strategy, that is dynamic. So when we receive a certain feedback saying that we didn't put it enough, so we have increased the communication. And when people have been caught some sort of aware of it, we slow down on the communication as well. All right? So as a conclusion, I would just say that it requires a lot of engagement. We did it over the last 2.5 years. There were a lot of screwballs in a way that we never anticipated COVID-19 to happen. But after our proposal got approved, then COVID came. But we knew that we had to do with it, so we introduced the rebate program and so on. So there are a lot of fine-tuning along the way, but the most important part is to stay resilient about it and try to achieve and aim for the finishing line. With that, I thank all of you for listening, and I'll be happy to answer any questions later on. Thank you.
Thank you. Now the next speaker is Dr. Renu Vyas, Professor and Head of the Institute MIT School of Bioengineering Science and Research.
Thank you so much. Good afternoon, everyone. So for past 1.5 days, we have been listening to policymakers, to consultants, to industry heads, and now it's time to listen to a teacher. But don't worry, my lecture will be anything but boring. So far in my career, nobody has slept in my class. So with that note, let me just start. So myself, Dr. Renu, and I'm heading the School of Bioengineering Sciences and Research. We are a constituent unit of MIT ADT University. I've done my PhD from CSR NCL, and I did my postdoctoral research at the University of Tennessee in Knoxville. Have a number of papers, publications, and written books. And for last 12 years, I've been working in the field of AI/ML for healthcare, and recently I've shifted towards environment also. Yeah, so this is the institute. I helped the management in starting in 2016. We had that time 30 students in the first batch, and now we are having 600 students. And currently, I'm also heading the School of Food Technology with 800 students. And the university itself has more than 10,000 students. And the main mission is to use the solutions, to use the bioengineering solutions for healthcare and environment, and both are definitely related. Today is about environment, so I'll just focus on those. This is a snapshot of the institute. I've already mentioned about the number of students, and we are having good H index and all. And also we have a very strong industry connect. So the major difference between other institutes and ours is we focus more on the live projects. So everything is hands-on. So these are the focus areas of research. I will just talk today about environmental. Again, SDGs we know enough, and our syllabus is really geared towards the objective of achieving the SDGs. So these are some of the projects we have already done, and most of them have got funding or awards from the government, and also some of them are good industry consultancy projects. So mostly we work on sensors, and we have developed sensors for environmental monitoring. Here you can see we have developed a sensor for detecting antibiotics. In India, major problem is the antibiotics available off the shelf, and then they are getting entered into water bodies, and this problem of AMR is happening, the antimicrobial resistance. So we have trying to develop a portable, very like point-of-care device, so that we can detect these antibiotics in the water bodies, and very useful for regulatory as well as for the industry. Another project, I'm myself very passionate about this, is the India sitting on a plastic bomb. So many of our projects are geared towards solving this plastic menace in India. So we are trying to find alternative sources of plastic, so we used banana peel for that. Also, from plastic waste, we are trying to develop fuel. This is a work done with a company in Ratnagiri district, where we were able to convert this waste into a fuel. And not only that, we also got white wax, which they could commercialize, and they were very happy. This is about generating bioethanol from paper waste, and for this we got the KPIT Sparkle Award. And this is menstrual waste. This plastic in sanitary napkins is just put in landfills. This stays there for 200 years, and nobody worries about it. And we have developed synthetic bacteria that can degrade this. Right now the conversion times are low, 2 to 3 months, but we are trying to work on that. Other environmental projects, so we have also undertook the Maharashtra government's Machi Vasundhara project, where for 40 ULBs, we were able to give them the data. And the students worked for a record 8 days, and we were able to hand over the data for the carbon footprints of 40 ULBs. And very interesting observations came from that. Also, our university campus is along Mula Mutha River, so water hyacinth is a major problem. So we have tried to not only just remove this water hyacinth, we also try to convert it into activated carbon, which can be used. And also we have worked on an Indian squat type toilet, which uses very less water. I have not shown it here. And all these efforts have given us reward. Last year, we got 6 projects finalized in Smart India Hackathon, and 2 of them were the national awards. One of our team got also a chance to meet Honorable Prime Minister. And recently, very proud to say this, we won the Wipro Climate Challenge Award, and we got this from Premji. And here the students' innovative idea was to make bioplastic from food waste. So coming to today's thing, we have already, I think all of us are unanimous, and there's a consensus that these are the problems facing the landscape, the urban water landscape. And we have all discussed all this. If there's something else, please let me know. So whenever there is a, kuch bhi vipda aati hai, to ek superhero aata hai. So the superhero for me here is AI. And I'm telling you, it will be a game changer, a great leveler. You can do algorithm here or in a first world country. So it's the same. And just imagine, every tap, every valve, every pipe, if it is getting patrolled by AI, even at a very small scale, the cumulative effect of that, it's mind-blowing. So all this guy doesn't need ammunition, just needs data. And of course, a domain knowledge, so that you can take actionable insights from that data. All right, so why to make sense? Because the way we are getting bombarded with data, and most of this now data, we are not saying just data, we are talking about big data with velocity, veracity, volume, being thrown at us in a day, which was like a lifetime during 1700s. So we need to make sense. If we do not make sense of this data, we will drown in the data. All right, so conceptual AI, ML are generally used as synonyms, but I just want to tell that AI is the bigger one, and that you have ML. We are using statistical tools to build machine learning models. All right, this is the common pipeline. I have written books, you can refer to that. Yeah, the applications, I'm very thankful to yesterday's speakers from Bentley and I think L&T. They've already talked about smart meters and all, IoT enabled, tamper-proof, and this can be really, make a lot of difference in the water landscape monitoring. So basically, if I were to, in fact, 10 minutes are too less, but basically if I were to, concise the whole presentation, there are 3 important things where AI can play a very major role. And one is to optimize water management for achieving efficiency and for adapting to climate change. So I'll just mention only in passing. So these are the points where we can use predictive analytics for supply demand management, water distribution networks, water quality monitoring, remote sensors we can use for water resource monitoring, and to enhance efficiency, ML-driven optimization tools. So if you can also take care for, say, maintenance of your instruments, that increases efficiency. Also, we can foster community engagement because you can have personalized, records for different customer behaviors. So, of course, the most important is the climate challenge. So, sudden climate events like cloudburst or flash floods and all that, we can, use this AI/ML techniques for predictive forecasting. And these are the other ones that have not been discussed, even related to biology. And I recently met the director of IITM in Pune, and he was said, they are getting now into biometeorology, which is really very interesting because we know that environment and healthcare affect each other. So these are the important data sets. The presentation will be here. I can share it with you. Please go through it. These are the data portals which have the publicly available data. And this is what we are doing at our institute. Very quickly, just 1 second if I have, I'll explain that, sir. Flash floods, I was surprised not many people talked about it. Flash floods is a major problem now happening. And what effective way if you can develop good nowcasting models. Say a period time of 6 hours if we can predict. Only thing, it's very complicated, very challenging, and we are also ourselves struggling with data. But I think these are the important attributes if we can look into the drainage network. We can use LiDAR, radar, drone technology to get the elevation, water elevation levels. We have done this test flight already at our university campus with the drones. And satellite data, of course. Even cloud density data. Meteorological data, sensor data. If all these can be, these are all heterogeneous data sets. If all can be combined, and if we can develop good nowcasting models, I think at least we can try and attempt to, predict these flash floods from, occurring and take mitigation steps. All right, so. You can refer to these books. We are right now working on genetic programming. These are evolutionary based algorithms. Here it's compared to ANN here, which are like black box model. Here you come up with mathematical equations. So here the genetic algorithm throws mathematical equations. So you also understand what is the correlation between the various variables in your data set. All right, so thumb rules, this is not given in any textbook. This is based on my experience. I'll not go through each, but I'll tell you quickly that if you have good statistical tools, it is good enough. You don't have to use AI/ML if your stats is just giving you good insights. So where you have to use, you have to be very careful. You should pre-process the data. You should normalize the data before using, and then try your whatever regressor or classification models you want to build. And another thing is about data dimensionality. Don't make it too complicated a model. Try to make it a very parsimonious model so that the minimum number of descriptors that are there or the encoders, I think the better the model will be and more robust and resilient the model will be. So these are some rules of the thumb. These are also there in the textbook. You can just go through them. And also validation is very important in any of the AI/ML related work, whether you have validated the model correctly. And there's very standard validation metrics. And of course, the best is again get it vetted by a domain expert. All right, so thank you so much for listening, and we're very happy to collaborate. If you want to have ideation, I'm looking for actually problem statements from all of you, so that we can at our institute do a brainstorming and come up with say 10 feasible solutions, and one you can pick up from there. That's the way we have been working, and we can co-create. Another way is we can outsource. If you have a well-defined project or falling short of time or something, you can just give it to us. Academics, we have a little more time than you all. So that is one thing. Third thing is prototyping. So we have very good prototyping facility at our university with all 3D printers, CNC machines, lathe machine. In fact, we have one of the best design schools in the country with all design workshops. So if you want to develop prototype also, you can do it. And then later on, you can talk to the industry for scale up. Right, so connect with me on LinkedIn, or this is my email ID, the fastest way to connect with me. And also go through our website for more details on what we stand for and we do. Thank you so much for a patient hearing.
Thank you, madam. Thank you, madam, for your good presentation. Next one, Dr. Prasanna Jogdio, South Asia Operating Manager, International Water Association, Chennai. Please.
afternoon, everyone, and it's a pleasure to be here. I would like to thank IWWA for inviting me. And so yes, I am going to talk about impacts of climate change on water, and I'm going to give IWA's approach. So before I begin, I should talk about what is IWA. So IWA is International Water Association. We are a global membership organization. So at IWA, we have around 10,000 plus members globally, and they are all connected to each other through a platform that we have, which is called as IWA Connect Plus. So you can call it as LinkedIn for water professionals. So that is something that we have. So all these members, they are divided into certain groups, or they choose which group do they want to be part of. So specialist groups, we have these 50 plus specialist groups. These specialist groups are niche areas related to water, where all these water professionals, they can work on these problems. They can be part of the committees for these groups. So these are semi-autonomous groups that we have. We also have young water professional chapters in several countries. We have slightly liberal terminology of young. Everybody who is 35 and below can be called as young water professionals. So for all these members and all the specialist group people, what we do is what we are good at. We are good at holding conferences. So biannually, we have World Development Congress, and every alternate year, we have a World Water Congress. So last one we had was in Copenhagen, and the next one we are going to have is in December in Kigali, which is a development congress, and next to that is the one in Toronto next year. So I would like to invite you all to be part of those conferences. And all the information or knowledge that is gathered through these conferences, as well as the conferences which are managed by these specialist groups, all that material, all that knowledge is combined, and we analyze it, we put it together nicely, and it is available for all the members as IWA treasure chest. So everybody can have access to that. Now, when you go on Connect Plus, this is what you see. So you can see here that there are a lot of things, specialist groups, cluster groups, task groups. So you can choose according to your liking. You can get connected to people throughout the world. So that is the power of Connect Plus. You get connected to everyone in the world. So it's just an example. This is my profile, as you can see it on Connect Plus. Now coming back to the topic for today. So we all know from yesterday we have been listening to this that climate is changing. Yes, and there are a lot of effects. So what are the impacts on water? So I'm going to talk about a few impacts on water. So we all know that the weather patterns have been disrupted. Then extreme weather events have occurred, floods and droughts. Then unpredictability of water availability. So that is something that we have been discussing a lot in this conference. Shrinking of ice sheets, because that also affects the availability of water in certain parts of the world. Then rising sea levels, it can affect the salinization of groundwater. So all these impacts that we have been seeing about water, so that poses a question, are we really water smart? And how do we say that we are water smart? So first we need to ask a question, where do we need water? So I think there are 4 areas where we predominantly need water. Water for cities, then maybe water for industries, water for nature, which is something really important, and we all have been neglecting that. And the last one is water for agriculture, because we are an agricultural country. So these are the aspects, or these are the areas where we actually need water. And so when we say we need water, but what we are doing is we are catering to our wants. So how do we cater to the needs? And then the question is, while catering to the needs, can we still be climate smart? So so we are trying to find these questions through IWA. And how we are trying to do that, so we have a program called Climate Smart Utilities. And through Climate Smart Utilities, what we are doing is we are focusing on 3 major aspects, which is adaptation, mitigation, and leadership. And what we do is we go to different countries, we go to different utilities, we ask them what their best practices are. We compile them together, and what we do is in our conferences, we recognize them. So they get to travel to the conferences, they get to put forth their best practices in front of the world. So these are some of the case studies that we have got so far. So in Kigali conference, there will be a few more water utilities coming in and showcasing what the best practices that they have. One of them is going to be, I think, Municipal Corporation of Karad. and I think Odisha Water Corporation is also going to be there. So I invite all the utility representatives here to take a note of that, and you can get connected with all the utilities in the world through this platform. So what else can we do to understand the problem of water security? Now, the thing is, what we can do is we can ask questions, and that's what we have been doing. So how do we decide the importance of these questions? So the way I would categorize it is by categorizing it as a question of unknown. And I will differentiate that unknown in two parts, what is knowledge and information. So knowledge is something that we have been gathering through academia, through all the research that we are doing. But in past few years, with the climate change, there are many questions which are posed in front of us. So there are a lot of gaps in the knowledge, and that we have to look at. So that is a question of unknown. And information is basically awareness that we need to look at. Every person should know the importance of water. So this cartoon gives you a good idea about what do I mean by awareness. People don't know basics of water. Now, what IWA is doing about it? So when it comes to research or academia, whatever knowledge is generated, we have 15 plus journals. So we publish them in these journals. So water research, one of the best journals in the world for water, is IWA's journal. So you can get access to these. We keep having these webinars where people talk about problems related to water. Then we also have something called a source magazine, where, as I said, these journals are more towards research or academia, but source magazine is more in layman terms, which is more understandable to common public. Now, the second question is question of untapped, and we have already started talking about it since yesterday. So that untapped is something which is reclamation of water or reuse of treated water. And so what we have seen till now is Chennai Metro Water has been using 13% of the water that they're treating. Or Surat Mahanagarpalika has also been using 16% of water that they're treating effectively. What we are doing is we have specialist groups who are looking into these aspects. We are looking at water reuse, we are looking at sustainability in the water sector, and we also have conferences. So we had a conference earlier this year about reclaimed water use. So these are the, I would say, platforms which IWA is trying to provide to people who are working in these areas. Now moving further, along with these questions, there are multiple other questions that we need to think of. One is regulation of supply. So I would say most of the government institutes or utilities, they're more focused on regulation of supply. And of course that is important. But however, at the same time, we need to look at demand management. So we need to look at the consumers, how they are utilizing the water. Next one is considering the upstream. So when I say upstream, I don't just mean mountains or where the water comes from. It's also upstream cities and downstream cities. Take example of, let's say, Pune and Solapur. We know what is happening, that all the wastewater from Pune is going to Solapur. And that's a very burning question. So we need to look at these questions which are related to upstream and downstream and work on it effectively. Then also role of environment, which has been neglected for years, but now we are taking note of it. Now, when we look at all these questions, the question is, okay, how do we approach them? So can we have a different approach towards it? And this is something which I can talk about, or I can suggest, is basically we understand the problems. While we understand the problems, we have a holistic approach. We have historical knowledge related to the problem. Once we understand the problem, we need to ask relevant questions. So when we ask these questions, we need to learn from the failures as well as success stories that we have. So when we learn from these, then we can actually ask pertinent questions. And when we ask pertinent questions, related to those questions, we need to generate knowledge. So to generate knowledge, we need to discuss these problems. Of course, as Dr. Vyas said, we need digital tools for that. We need to collaborate with people. The knowledge has to be shared. And that is exactly what we are trying to do as IWA. We are trying to share that knowledge. So once we have that knowledge, we need to design effective solutions. And again, we need contextual thinking for that. We can also take help from AI for designing these solutions. And then we need to, after designing the solutions, we need to manifest the results. Once we manifest the results, we implement. Once we implement, so again, stakeholder participation, it has to be an interdisciplinary approach. Because we can't say that for a water body, hydrogeologist is not important,
or a botanist is not important. Everybody has to be there. It has to be an interdisciplinary, multidisciplinary approach. Then when that happens, we need to start operation and maintenance. And while operating, and while doing that, we need to infer from the data that we are getting. Because when we get that data, we start asking the questions again. We start understanding the problems again. So it can be a circular approach that we can take. And something that at IWA we strongly believe in is digital water or digital tools is something that will enable us to have this approach. So at IWA, we have a program called as Digital Water, where we have webinars, we have conferences related to digital water, we have white papers, we also have books which are published related to digital water. Recently, we have had a subgroup in India, which is working on digital water. So I would like to invite Dr. Vyas to take a look at that group as well, and we would be happy to have you as part of that group as well. So these are the things that we are doing at IWA. So last but not the least, again, I'm putting it out there. So these are the conferences that we have, and we invite everyone to be part of this and to be part of all the programs that we have, become an IWA member. Thank you.
Respected Chairman, dignitaries on dais, enough dais. As earlier speakers have already spoken on the climate change. I shall be also speaking on the climate change impacts on the urban water resilience. I'm Dr. D.P. Singh, a retired engineer-in-chief and past president of IWWA, having experience of 40 years in water supply and environmental management. Yeah, it's not going. My presentation will cover the scenario attracting attention and actions for the actions. And the climate cause for climate change impacts, climate change implication, climate change mitigation, adoption, and then the, resilience, urban climate change resilience, and then India's initiatives on this climate change. If you see the scenario, the last decade we had the warmest season. We had a lot of floods, lot of droughts in different parts of the world. And temperature rise, if you just compare with the temperature rise, in 2020 it was 1.2 degree was compared to the pre-industrial era. And therefore, if you see this, if you see the impacts of climate change, I've already given a scenario. Then certainly, are we happy with this scenario? No, absolutely no. Certainly each and every citizen, each and every person, entire globe, pan the globe, are worried about this climate change, especially impact on the water sector. What is the cause? Cause of climate change is the emission of the GHG emission, greenhouse gas emission. This is the main cause. And then we have the natural cause and then human activity cause of human activities. This, if you see this, the slides, we have got the 76% the share of the carbon dioxide. Methane has got about 14.3%, but global warming potential of methane is 25 times more than the carbon dioxide. If you see that N2O is only the 7.9%, but the global warming potential is 210 times. Then certainly we are worried about the emission of the CH4 because we convert the emission in terms of the carbon dioxide equivalent. And if you see this fossil fuel, the burning of the fossil fuel is contributing the maximum 74%, and biogenic is also contributing 22%, remaining is others. If you see this, sector-wise emission, the energy supply has got a 25.9%, is major one. And then which one is important for us is the water supply, water and wastewater, wastewater and the waste, that includes the solid waste. And that's the contribution is about 2.8%. But if you see these slides, if you see the compounded annual growth, will be surprised to see it that in 1994 it was only 1.9%, and in 2007 is 7.3%. The compounding annual growth is about 7.3%, much more than the other sectors. Therefore, we are very much worried about this, impact, the impact of the water on the water sector. See what is happening. What is happening on the effect of the impact of the climate change? The drought, we know, because we have got the decrease in precipitation, we have got the increase of precipitation, we have got increase in temperature, and also the sea level rise. If you can see the impacts, it's just already there. As you can see, we have got, forest fire, we have got, drought, we have got, flooding, we have got glacier melting the glacier. And if you see this implication that's already there, the key issues normally, worrying to us regarding the urban water, there's a rising temperature, the heat stress. Many parts of India, many parts like Rajasthan, even in Bihar, the southern part of Bihar is affected by the drought. And then we have got the sea level is rising. That's also causing attention of the planner, implementer. If you see this, this is a virtuous circle, because the climate change, if you have the climate change, we plan to have the disaster risk management, then we have development process. Also, when we go for the development process, that affects the climate, and that's causing impacts further. This becomes a climate change mitigation. Because what you have to do, you have to mitigate the first stage is mitigate, means reduce the emission of the greenhouse gas emission. Greenhouse gas emission is important. You have to reduce that, and therefore the 190 countries are signatory of this panel, and they are trying to reduce. They are trying to limit to 2 degrees centigrade. This is based on my study, because what I said, the water sector is also causing attention of especially water engineers, and we don't have data especially for this. The research conducted by me especially for the Patna, it shows that for the system having the different options of the sanitation, we have got the treatment system, wastewater collection system, a treatment system. If you see this, I've just compared biogas which is generated from the treatment plants. If you compare this, the biogas not flared is 0.198%, and when it's flared or used, the emission is reduced. Therefore, this is really a thing to be considered. What to do, whether we are allowing biogas to enter into the environment, or to flare it, or utilize it. If you just see, there is a reduction of 17 and 19%. If you see the septic tank is the on-site treatment system, and this is causing good, because this is unnecessary adding the cost. If you see the for families, it's about 50,000 cost we are spending, and if you just compare with the treatment plants, which is sewage treatment plants, centralized treatment plants, it's about 8 times more than the treatment system. And if you see the emission part with the septic tank, this increase is about 117% and 134%. Means what is happening, the anaerobic action is taking place in the septic tank. That is emitting the CS4. CS4 has got the GWP of 25. That's the reason the septic tank should not be there, because this has opened the eyes, especially to look into for the planning purpose. If you see the These are the different, adaptation, climate change adaptation process methods. You can think about this. This is there. Time is very short. If I see, I will just go back to the. How much time is there? 2 minutes. Okay. It is. So far as the adaptation is concerned, I've just put the first question. First is a reduction on non-climatic stress on the fresh water. It's not necessary that what is happening in the cities, what is happening in different parts of the world is because of the climate change. We have got the non-climatic stress, like we are discharging in untreated wastewater to the river system. We are discharging industrial wastewater to the river system. We are disposing the plastic waste. These are causing the stress on the stress. Therefore, the climate change is an issue there, but also the non-climatic stress that has to be taken care of. The use of rainwater, because what we say, our water supply system is based on the water supply, based on the surface water, groundwater. Conjunctive use is very important. That's the reason that we need to have the prospecting. This is surface water prospecting and also the groundwater prospecting. Each and every source has to be linked with, and such, we need to have the water quality mapping. Therefore, then we are not considering the rainwater. Rainwater is a big source. We are just, when we talk about just rainwater recharge, we are talking about the rainwater recharging. We are not talking about the rainwater use, how best we can use the rainwater. And also the grey water, we talk about this grey water means used water. We just, just the last session, Guptaji was saying that it's not a wastewater, this is used water. Used water has to be recirculated back to the system. And therefore, if you're considering this surface water, the groundwater, rainwater, and also the grey water, means the treated wastewater, used water, certainly you will be reducing the stress on the fresh water, and that will help in the designing the system which is impacted by the climate change. And therefore, also the renewable energy. What we just said, we are going for the conventional energy, the indirect GHG emission by using the coal as a source for the power generation. That has to be checked. Instead of the conventional electricity, you should go for the non-conventional energy, renewable energy, so that we can reduce the GHG emissions. Similarly, 1 minute. Time we have given very short. These are the India's initiatives and the mitigation measures for the emission. I've just given this. Time is very short. I'm not able to explain each and everything. Thank you so much. Thank you very much.
Yeah, good afternoon everyone, and thanks the chairperson and IWWA for asking me to make this presentation. I'll be I'll be talking about climate change and water technology needs. My predecessor has already spoken about the impact of climate change. I'll try to focus on some of the studies we have carried out ourselves. And if you remember this incidence of February 15, 2021, very recently, 2 of the plants in Delhi was closed. Sonia Vihar and Bhagirathi water treatment plants were closed because the turbidity reached as high as 8,000 NTU. And this was primarily because of glacier retreat in Uttarakhand. So you can imagine that the effect was felt 400 kilometer away from the glacier retreat. And unfortunately, because we didn't have a pre-sedimentation tank in these two treatment plants, the plants were closed and many residents in Delhi couldn't get treated water. So this is realistic. The impact of climate change is very, very realistic, and it's demonstrated clearly by this particular example. So my presentation outline is background climate change impacts on water supply. I'll specifically talking about the impact on water supply, not on water resources. A case study I'll be defining how it actually affects water quality and climate change adaptation technologies for water supply. This is very interesting, graph, which clearly indicates there are many, many impacts of climate change. And if you see on this axis, the population which are likely to be affected because of risk of hunger, risk of coastal flooding, and risk of malaria are much, much lower than the risk of water stool. At least 10 times of the population will be facing water scarcity due to climate change as compared to other impacts of climate change. I think we have talked a lot, but there are three distinct climate change impacts. One is increasing temperature, which will result in high evapotranspiration as compared to what we are facing right now. There'll be impact on water quality. I'll be detailing about it. There'll be change in precipitation patterns, and we already started feeling it. You remember that in our childhood, we were having monsoon right on 7th of June. Now it's extended to 7th of July. There'll be stream flow, water availability will be affected, intensity, frequency, and magnitude of floods and droughts. Groundwater recharge will also be affected consequently, and there'll be rise in sea levels. And then part of Gujarat had already started feeling because the TDS levels in groundwater started increasing. So I think I'll just recap of what Professor Hemant Kassan talked yesterday. There'll be increased water scarcity because of climate change, change in source water quality, and rise in water demand and transportation losses, high risk of inundation of water, incineration infrastructure. I think Bhandup water treatment in Mumbai is an example of 2003 flood, and this entirely got inundated, and high risk of saline intrusion. And this is a classic example, and then I think many reservoirs in India also facing the similar fate. And if you see the water level in this particular reservoir in South Africa near Cape Town, the water availability just got reduced from 800,000 million to from 2015 to about 0 in 2018, because there was more withdrawal and there was less, availability of water. So we'll be facing this in India as well. So I'll talk about water quality specifically because we are facing this picture here is from Nagpur in 2017 in August. We had a lot of green water in our intake of Kanhan. And the bottom is also from Nagpur of 2018 May, when most of the fish kill happened. And this primarily had happened because of something known as the cyanobacteria. So cyanobacteria are blue-green algae. It's already been demonstrated the potential of climate change. We are getting growing cases of algal bloom in most of our reservoirs. And this is a case from Latur. I think Latur was famous for water scarcity, but there's another problem which they faced in May 2022. And we have been called by a municipal commissioner over there. And you can see the status of Manzra Reservoir, which is almost 35 kilometers from Latur city. And they transport, and the entire reservoir is covered with this blue-green algae or cyanobacteria, we normally call it. The channel leading to intake well is also green. And then manual dosing of PEC is done. This is how our, your urban local bodies are treating their assets. Unfortunately, they don't have, they have several limitations because of which they are not properly able to operate their treatment plant. You can see scum formation in clariflocculator because one of the rotor was not functioning there. The leaking launders of clariflocculators and poorly maintained rapids and filter. This plant was set up in 2008, and I've been told that since then, the plant was not even once maintained. And this is the case from our Nagpur. You see the lamella chlorophyll was flooded with algae, and that had severely affected the say filtration rate of this lamellar chloride. So I'm coming to the point that algal bloom or cyanobacteria very dominating in India in many reservoirs, and that is adversely affecting say our sources. So I'm taking you to Nagpur, and this I'll be talking briefly about water sources. I'll be specifically talking about Kanhan River, which supplies almost 250 MLD of water to east part of Nagpur. And if you see our conventional water treatment plant, because we have one conventional water treatment plant, and then we collect water from source, and then we aerate it via aeration system. We have like pre-sedimentation also, coagulation and flocculation, and sedimentation, we have filtration and disinfection. So this is the conventional water treatment plant, and it is meant for the sources which only have turbidity or suspended solids in it, apart from some pathogens. But this was the condition in August 2017. You can imagine that this was entirely green. This is the intake to Kanhan water treatment plant. Because of scanty rainfall in August, we had this particular situation, and then say part of eastern Nagpurs were complaining about color in water as well as odor in water. They were not drinking water, and there was so much of hue and cry, and then we investigated this. So this entire part of eastern Nagpur got affected because of this cyanobacteria algal bloom, and then we did detailed investigation, and these are the like 3 water supply zone out of 10 which got affected severely because this problem of algae. What we actually done in this case is we did a detailed investigation on water quality and even enumerated phytoplankton and zooplankton, which are the major causes of cyanobacteria proliferation. And we have also done some field observations and interacted with the water treatment plant officials and some of the consumers. And we devised some of the strategy, because the only thing which we can do in this case is that we have to increase the pre-chlorination dosing. So we increase it from 0.5 to 1.5 to 2.5 by having, say, pre-chlorination dosing. At the same time, we have increased the polyaluminum PAC dosing also to 10 mg per liter, as against almost, say, 1 to 1.5 mg per liter we normally use in say, normal condition. So you can see the turbidity was 36.3 NTU. So in water scarcity, you hardly have turbidity of like 5 NTU. But in this case, it was jacked up to 36.3 NTU because there was a, say, algal proliferation. And then we monitored, we added. And then fortunately, the turbidity got reduced to 1 NTU at the outlet of treatment plant. We continued monitoring up to ESR also. There also you can see the turbidity was not much affected. That really helped us to bring down the turbidity to say almost 2 NTU, and now you know that our standard is 1 to 5 NTU as per 10500. So we could bring down this turbidity to almost 2 to 2.5 NTU, and then consumer was actually accepting that water, and with the available, say, chemicals we have available approaches, we could optimize this treatment plant, and then we can say remove this particular algae. Fortunately, what happened on 20th August 2017, there was a rain. And you know there's rain, there are so many inorganic material which flow through river, and then it's very easy to coagulate and flocculate as against organic matter. And then at a very normal dose of 0.5 mg per liter of chlorine at PAC dosing of 1 to 1.5 mg liter, we could bring down the turbidity from 24.2 NTU to almost nil at 0.1 NTU. So this had actually helped, and this is what we actually suggesting to many ULBs which are facing similar problems. But this is not the optimum solution, because unless we retrofit our existing water treatment plant, we will not be able to handle this particular problem of cyanobacteria, algal bloom in water. So if you see the example of Puri or even Surat also, they're going ahead with modification in water treatment plant. So what we can normally do, this is the conventional, the only problem which happens in pre-chlorination is that dissolved organic carbon increases because there's a lysis of this algal cell. What can be recommended in such cases, and then we have to prepare ourselves to handle such situation, is that we have to have, of course, coagulation, which can remove intracellular toxins. We have to have like PAC, powdered activated carbon, not polyaluminum chloride, that can remove extracellular toxin absorption. And we may have to also have ultrafiltration for flock removal. So unless we have this combination, it will be very difficult for us to bring down the turbidity level to less than, say, 1 NTU. This is the last slide, and then there are several adaptation technologies which we need to adopt and to face the climate change repercussions. These might be, say, some of the adaptation measures we can even initiate in our ULBs to face the climate change. First is like municipal or domestic supply side interventions can be, we have to increase reservoir capacity, we have to desalinate. There are many cities which are also going from Bombay also, we got a proposal from MCGM, we have to compare desalination option against bringing water from Vaitana. So I think we are even thinking about having desalination in many coastal cities. And we have to go for industrial cooling and industry cooling. There were several examples given where the water is being used, treated wastewater is being used in industries, a thermal power plant. Flood management, we have to build reservoirs and levees, protect and restore wetlands. We have to even improve flood warnings and curb flood plain development. So that's all. Thank you very much.
Thank you, Dr. Pawan, for completing your presentation in time. Now we have, in fact, we have crossed 1:30, but still we'll take some time for some question answer.
Numerous application also, sir. So is there any device to, rather than destroying them, we can use in agriculture, pharmaceutical, and there are numerous applications. I have written 2 books on application of the marine algae in various fields, sir. So my humble suggestion to you, is there any device we can, rather than destroying the algae, we can use somewhere in other fields, and so both the purpose can be solved, sir. The application part of the algal blooms as well as the water treatment. That is my humble suggestion, sir.
I think that's really good point. And then we also did some studies in which we tried to harvest algae and prepare even briquettes also out of it. But what happens then normally in most of the places where the water sources are contaminated with nutrients at all, removing algae is also a big problem. Then harvesting and then drying it up and reusing is really an issue. And that's why I think most of the ULBs are finding it very difficult for harvesting and reusing it. But your point is well taken that we can definitely look for this solution. I know, but sir, practicality of it is a big concern.
I have written a book with CSI.
Yeah.
Dr. Sure.
Yes, any other question? Okay, so it's nice. We had 5 presentation in this session, and Mr. Ajwan talked about the tariff management, and just to recover the expenses and not to charge the consumers. And he talked about the things that was done in Malaysia and how he could do the small change in tariff, maybe after 28 years. Then Dr. Renu Vyas talked about the artificial intelligence and its application to various fields, and that have been done in MIT School of Bioengineering. And he talked about the urban flash floods and other places where this technology can be used to predict what is going to be there or how much is going to be the flood in a shorter time. Then Dr. Prasanna Jagdev, that from IWWA Chennai, he talked about the impact of climate change on water adoption, and talked about the various problems which are there because of the impact change. Dr. Dineshwar also talked about the same thing, and then he talked about the Indian scenario and what are the carbon dioxide emission which are there, and one more thing that he mentioned about the septic tank. Emissions of greenhouse gases are more in case of the septic tanks. Then the last presentation was by Dr. Pawan, and he has taken a case study of Nagpur city, and then also talked about what has happened in Delhi, and why the 2 treatment plants were closed because of this climate change impact. So I congratulate all the speakers for their nice presentation, and now the final words from Dr. Mathyanalgan.
Thank you, sir. All the speakers done very well. I thank you. Thanks on behalf of to all the authors. Thank you, one and all.
Thank you, sir. Now I request Mr. Bharat Wankhede, AC, CPDM, MJP, to felicitate the chair, our Vice President, Mr. Muthu Malayalagan. Thank you, sir. Now I request Mathur sir to felicitate the chair, Dr. Rajesh Gupta ji. Thank you, sir. Now I request our Vice President to felicitate the speakers. First is Mr. Azun Ahmed Jahedi. Go there. Dr. Renu Vyas. Dr. Prasanna Zogdev. Thank you. Now I request Dr. Rajesh Gupta ji to felicitate our past president, Dr. Dinesh Prasad Singh ji. Now I request Dr. Rajesh Gupta ji to felicitate our friend, Dr. Pawan Lapsetwar ji. And in the last session, by one Mr. Sagar Patil's felicitations was not done. So I request him to come on the stage and thank you, sir. I am thankful on behalf of the IWWA to all the chairpersons as well as the speakers, and I request all the participants to proceed for the lunch. Thank you. I request the next session's speakers to give their presentations on the backstop. Thank you. Of the water management, water and the livelihoods in the global south, gender perspective in water management, water pricing and affordability, economic valuation of the water resources, water related conflicts and cooperation. And I request Sri K.K. Songaria sir, Chairman IWWA Bhopal Center, to chair this session. Thank you, sir. I also call the speakers Dr. Ravi Kumar Joseph, Senior Water and Sanitation Specialist and Consultant, World Bank. Sri Ajay Kumar Sahu, Chief Engineer, Public Health Department, Chhattisgarh. Our past President, Mr. R.N. Gupta sir, former Chief Engineering in Chief, Public Health, Chhattisgarh. And Sri Sudhakar Hande, Executive Engineer, Water Supply Project Management Department, Municipal Corporation of the Greater Mumbai. So now I hand over to Songaria sir for the next proceedings. Thank you.
I welcome you all in this last and sixth session. ये हो गया? हाँ, ये कट है. ये इनकी जगह ये रहेंगे. In this last and sixth session of 2 days international convention, which is very fantastic in all terms, I would like to invite first Shri Ravi Kumar Joseph ji. He is a senior water and sanitation specialist and consultant in the World Bank. I would like to invite the attention of the speakers that 10 minutes is allotted to every speaker for this convention, for this session. Thank you.
Good afternoon, and many thanks to the organizers for this opportunity to talk to you about the social economic aspects of sanitation. So I try to keep it brief. I just have a few slides to start a discussion. So we heard all through the day, the last 2 days, about climate change and how it impacts water availability and what can be done to improve the water that you have and all that, which is very nice. But at the same time, I think it's also useful to think and reflect upon who are we trying to serve, and how, and more importantly, focus on the marginalized and the low-income communities, right? What is the level of service that they have? Why are they having this kind of service that they have, and what can be done to improve those? So it's remarkable the kind of progress that has happened in India, especially on sanitation, since the launch of the Swachh Bharat mission. We are now declared open defecation free. But so if you look at this slide, this is from the JMP data from 2022. It shows us that we are almost, we are open defecation free. But I think what is of concern is the amount of waste that is safely managed. right? And that's something that we need to be concerned about. This grossly, while it presents a good picture for what the country has achieved, but if you start to dive deeper, and then you start to look at the wealth quintiles, then one tends to see that, especially for the poor and the poorest, just look at the number, the percentage of the unimproved toilets, and look at also the percentage of safely managed, and other things as well, right? So that's a bit of a concern, and that's worrying, right? I mean, so who then are benefiting, right? I mean, all these larger programs are benefiting essentially the rich and the middle class. And then when you dig even further, and then you start to look at, in the informal settlements, look at communities as well as look at, scheduled castes and scheduled tribes, that gives even more, a worrisome picture. So then you start to look at, okay, this is regarding the access or the availability of toilets. Then when you start to look at what happens to the wastewater or the fecal sludge that is generated, what really happens to that? This is something which was done by Athena, and what they are saying is that less than 30% of all the wastewater or fecal sludge generated in the country is safely managed. And that's worrisome, right? Because so much of investments have actually gone in, and we aren't seeing the outcome that is desired for. And then when you start, this kind of data is not available when you start to dive deeper and start to look at what is the amount of wastewater or fecal sludge that is generated in low-income communities and how is that managed. That's even more, startling and of concern. So this is the case of Delhi. So if you look at Delhi as a whole, over 50% of the wastewater or fecal sludge is safely managed. But when you look at two low-income communities, it's less than 10%. And what does that mean? I mean, when you have such low levels of access, and then you have these wastewater which is not properly treated, obviously you're going to have, and then you start to look at sanitation workers, right? I mean, who are the sanitation workers? I'm talking about those who are involved in across the entire sanitation value chain, from the construction of the toilets to the emptying of the fecal sludge, and then the transportation, and then the treatment. Primarily, these are people who are the informal workers and who do not even know what their entitlements are, and they are exposed to or work in environments which are so harmful to them. So in addition to what they call a double whammy, right? They live in areas where you do not have your conditions of environment is so poor, and over and above that, your working environment is also so poor. So what are the recourse do they have? So the country has several legislations which prevent what you call manual scavenging. But what's startling to know is that over the last several years, the conviction rates have been very, very low. So either there is no reporting happening, or those which are reporting is not getting captured. So all that means that when you have such poor sanitation, there is a great impact on the health, the environment, and therefore on their economy as well. So the World Bank did a study which has evaluated and estimated what is the economic loss to the country because of poor sanitation. And what they found was that the country, this study was done in 2011 using 2007 data, and what they found was that the country loses something like 2.4 trillion rupees, equivalent to 6.4% of the GDP. And the significant portion of that was because of health-related impacts. And then, of course, you have health, and then you have water, and then you have the time lost because you have to take care of, your children are sick or you are sick yourself. And lastly is the tourism loss as well. So when you look at health numbers, right, that's quite startling. It's close to about 800,000 deaths every year. And almost 10% of all the deaths in India is because of sanitation-related illness. And most of that, about 80% of those deaths are children under 5 years of age. And most of the deaths, about 600,000 of those deaths are due to diarrhea, 90% of which are in children. And when you start to look at, again, disaggregated data in terms of who are the ones who suffer the most, it's basically the urban poor. They suffer twice as much, they spend twice as much as what the rich people have. And the poor in the rural communities spend about 1.5 times what the rich people spend. And the poor in the rural areas bear the highest economic burden because of this poor sanitation. So what can we do to improve sanitation, right? I mean, in addition, so if you start to address these anomalies, right? First you start to address these inequities that exist in both the access to sanitation, and then we start to address these inequities in both of the treatment as well, then there is improvement, not just for those who live in those areas, but also to the country as a whole. By improving sanitation, you will be able to avoid about 350,000 deaths every year, and roughly close to about 350 million cases of illness every year as well. Not only that, because you're improving sanitation, there is also an added benefit that, there's also added benefit because there is investment going in, and there's opportunity, across the entire chain, both from infrastructure creation to the maintenance of those, and then for sanitation as well. So my humble thing to all is that, when considering projects and when designing projects, please do design systems that cater, that has an element that we need to provide services to all and not just to cater to the rich. One of the classic thing that we heard and during yesterday's presentation was that while you're providing services, the reason why informal settlements are left out is because of issues of tenure. And whereas the government of India is very clear that you need to de-link tenure from provision of services, still what really happens in the ground is true from reality. So I think it's good that we ask ourselves, who are we building, who are we who is this to be, who is to benefit, and it should not be that systems are designed and that the rich people enjoy all the benefits, because sanitation is a public good and the public good should be enjoyed by all. I thank you and thank again the organizers for this opportunity.
Thank you, Joseph Saab. After a very good presentation of Shri Ravi Kumar ji, I would now like to invite Shri Ajay Kumar Sahu ji, who is a good friend of mine and Chief Engineer in PhD at Jagdalpur in Chhattisgarh.
Good afternoon, everybody. Thank you to organizers for giving me opportunity, respected dignitaries on dais, learned delegates. My presentation is regarding drinking water source security and its sustainability, adopting scientific technique using remote sensing and GIS tools. Flagship program Government of India is Jal Jeevan Mission, Har Ghar Jal. As per this policy, this is a paradigm shift from the earlier system. Har Ghar Jal itself is self-explanatory to provide safe and potable water to every rural household with adequate quantity of prescribed quality with sufficient pressure at regular sustainable basis over full design period through protected piped water supply scheme. This is very self-explanatory how level of rural water supply scheme we have to provide. This has been envisaged in the Jal Jeevan Mission. For urban, Amrit 2 mission envisages providing water tap connections to household in all statutory town. A town means a municipal corporation, municipal panchayat, Uh, corporations we have covered under Amrit 1. So this is Amrit 2 is the smaller urban town. Every household has to be provided connection. Source sustainability, that means whatever the source are there, their regeneration is also a part of mission. And key to the Amrit mission is 24/7 from drink from tap. This urban water supply scheme, our vision is 24/7 water supply scheme. Next government program regarding water, though it is not related with drinking water, but it is related to water, is doubling the farmers' income to ensure food security through through groundwater management with the improved community and technical handhold support. So these are the Government of India initiative. As far as drinking water is concerned, as I have mentioned earlier, paradigm shift is from hand pump or stand post to supply water to every household level through functional tap connection. Functional word is very important because taps are prepared, taps are constructed, and it is a functional or not functional, mostly it is not looked after. But functional here means that this water has to supply from the tap. Ensuring service delivery, as I have mentioned, that means prescribed quantity as per norm 55 liter LPCT per day, quality as per IS 10500, parameters have been defined for 13 parameters. The quality, then pressure as per CPHU norm. At present, norm is minimum pressure at the farthest point or the highest point, whatever is the situation, 7 meter minimum pressure has to be maintained in the critical point. This service delivery we have to mention, and the source should be sufficient to run the throughout year, and the full design period, which has been considered as a 30 years. Challenge here is with the exploitation of groundwater across the country for various purposes and in scanty rainfall as well as drought-like situation due to the climate change effect resulted in depletion of groundwater table or yield of the tubewell, yield or drying up of the sources, as well as higher power consumption in our motor pump installed. Apart from this, water quality also deteriorating due to creating health issue. More the depth of the water we take out, more is the susceptibility of water quality in those. We have encountered this when water was available in the less, the quality of the underground water was very good. Later on, when there was a depletion, there is an increase in water quality. Most of the area, Rajasthan, we are facing TDS, fluoride. Some part of Madhya Pradesh, we are facing fluoride. Chhattisgarh, we are facing fluoride, some part arsenic and TDS. Likewise, Odisha, fluoride and iron, and Assam, Bihar, Jharkhand and UP. These are all now facing arsenic problem. Earlier, this problem also was not there because the water was available just below to ground level. Or surface water was used. But जैसे जैसे हम use कर रहे हैं, when the depth is increasing, water quality issue is also increasing. We are providing a sufficient quantity of water, but another aspect, the quality has generated that has to be looked after. Either it is a Jal Jeevan mission or Amrit mission. Necessity at present is the water security and sustainability of the source, which should be climate resistant, and need to ensure successful appropriate planning, design of the system adopting scientific technique using remote sensing and GIS tool. Solution is definitely where there is a problem, there is a solution. Need to identify suitable drinking water around the village or town. with the through now here comes the technological intervention. With the invent of technology, it has been suggested to use hydrogeo morphological map, HGMA we call it. HGMA map, basically it has been prepared by NRA SC, but it is available is to 1:50,000 scale. Same scale as our topocity is available. This 1:50,000 we can get the basic data, but it doesn't give a pinpointed data. We need pinpointed data. I will come in my presentation. So a GM map needs to be enlarged in the scale of 1:10,000, where there is a problem. Not everywhere. Where we face the source is drying up, we don't have sufficient source, then we need to, with the help of 1:50,000, 1:10,000 a GM map, some solutions we can find out, I will tell you later on. It has been prepared by ISRO, identification of groundwater sources, location with the help of remote sensing and GIS. Groundwater prospect map consists, and the other thematic maps are also required, apart from HGM map. What is the drainage map, what is the soil pattern, all this also governs the availability of groundwater. The utmost importance is to ensure that drinking water sources is sustainable over the design period and can be achieved through planning, implementation, sustainability measures like rainwater harvesting and artificial recharge. That has to be also taken care of. HGM map can be used for the identification of site-specific recharge structure. As I said, where there is a problem, because making is 1:10,000, certain expenditure is definitely required doing all these things. So if we'll do for everywhere, lot of fund is required. So where there is a problem, we have to intervene in this fashion. Government of India has also taken initiative, Jal Shakti Abhiyan, Catch the Rain Abhiyan. It is selected in some particular district. Even Atal Bhujal Yojana is also Government of India's flagship program. It is also not open to everywhere. Where there is a problem of groundwater, it has been Government of India is allowed to do in that particular district. Even through Manrega, we also do groundwater recharging structures. But the aim of Manrega is to give employment for 100 days. But some recharging structures are also constructed under this program. Then I will say the process. We need the basic data like name of village where we are doing panchayat, block name, etc. like that, this basic data. Then geo-reference map we need. What is the reference of village with geo-reference? That means the coordinates, latitude, longitude of that village. Various thematic maps we require: drainage, drainage with stream order, drainage with contour, slope, drainage with watershed, sub-micro watershed, geology, lineament, fault, fissures, hydrogeological, and then all these maps are overlaid for making a decision. This is one case study we have done in Jagdalpur district, it's Chirpal village. My engineer said I will come there. There are at present 24 tube-well drilled. 22 hand pumps are installed and 2 solar pump is also installed. But in summer, only 14 hand pumps give water, and 10 become unfunctional. 2023 population is 1280, and 235 household is there, and as per norm 55 plus losses, we consider 65 liter LPCD is required at present. Through these hand pumps or power solar pump, 48 liter is available, but this is not a doorstep. Our Jal Jeevan mission says we have to supply water at doorstep. Since we don't have a sufficient source, reliable source, scheme has been though prepared, assuming that we'll get a sufficient source, but since source is not prepared, the pipeline laying work has not been started. until this identification of the source, which I'll tell later on. So sufficient source was required. This is 1:10,000 map, as I have cited. We have, with the request NRSC Hyderabad. This is showing some drainage, geology, geological fault, and lineament. But we did further. Here, our hydrogeomorphological map has lot of legends. What is the type of rock available? What is the probable depth of water available? I will show later on. This is the real HGA map, 1:50,000 scale. In this map, in legend, most of the basic data is available. From here, we can, preliminary investigation we can do. What is the type of rock? What is the probable depth of water table? How much whether tube drilling will be support to you, or some other type of structure we have to go. This HGA map is a very good tool for water engineers. This we have used, as I said, 1:10,000 scale, and this is in 1:50,000 scale. So real analysis can be done to 1:10,000 in large map. Then the other thematic maps are required, as I said earlier. Based on the study, we selected these, in these 4 types of rock, PLM, the plateau, slightly, moderately dissected plateau 68. These are the code name given. Accordingly, here we can see what is the anticipated yield, what is the probable depth. Here also, this PLM 64 only suggests that 100 to 120 LPCT water can be available. But this also further requires investigation. This is the preliminary investigation. Then this overlaying of all the maps, this gives us decision-taking step. When we overlay all these to 1:2000 map, it gives, and it is suggesting there are 5.5 sites, 1, 2, 3, 4, 5 given. Some solution can be found out. Further, we went for decision making. We used transfer this location with the help of GPS instrument, this 5-point location to the ground. Field verification we did with the help of geophysical survey using resistivity meter and special resistivity meter, electrical ERT machine, electrical resistance tomography, which is available in the University of Raipur. We requested them to please come with this, and they given the solution with their imagery map. Only 2 sites are advised for the source of drinking water in that Chirpal village. Okay, sir. First site is suggesting drilling up tube well we did, but we didn't found sufficient yield. Second point, as per recommendation, they suggested a dug well can be solution because the rock pattern is there. The dug well can hold the water, and underground more the depth, water is not available because it is the shale formation. So we did the dug well drilling, and we found the sufficient yield for the source of the village. So this is the type of source selection. Further, we did, when we take out the water, after some year it will dry up. So we have also taken care of the recharge points with the help of this technology. And they have recommended to the site what type of structure you have to make. All the points they have given suggested, whether boulder check gabion or boulder check cum dike you have to make. These are the my presentation, selection of good source and selection of site for recharge structure. What has happened in unplanned planning in Durg, we have Gajra water, and CM asked us to prepare further augmentation of that. So preliminary study in that water said 682 water bodies are there in 2019. Only 11 water bodies were suitable for recharge. That preliminary investigation we did. Further, in 3 years, more 82 more water bodies were prepared, and out of 764, 5 more additional bodies were suitable for recharge. So out of 764, only 16 point sites are suitable for water recharge. When earlier to that, in Chhattisgarh, with the leadership of our R.N. Gupta sir, this Gajra watershed we have implemented. This is very successful project based on the scientific technique what I have elaborated here. Watershed is covering 250 square kilometer area, consists of 46 villages, 59 habitation, 101 specific structures were identified using this remote sensing GIS application. Before implementation of this project, water level was below ground level more than 35 to 40 meter. After this implementation of Gajra watershed with the scientific, at present also water level is 10 to 15 meters. Farmers are taking now 3 crops. Earlier they were not able to take a single crop. Now with this Gajra watershed, scientific artificial recharge technique, they are taking 3 crops and water level is still 10 to 15 meter groundwater level. Thank you, sir, for giving me opportunity.
Thank you, Sahuji, for your good presentation on HGF maps, which is very much useful for our Jal Jeevan mission, which are being implemented by Government of India nowadays throughout the country in rural areas. Now I would like now invite Shri R.N. Gupta Sahab, former Engineer Chief, Chhattisgarh. Shri Gupta Sahab is a dynamic past president also of the IWWA, and he has served as at many places in Madhya Pradesh, and after new Chhattisgarh, he has been promoted and retired as an engineer in chief of the Chhattisgarh, and it is very heartening to see to note that he is working as a High Court advocate also nowadays in High Court of Bilaspur and Raipur also. Sir is invited now.
Namaskar. Thank you very much, Chairman. Mr. Chairman has been known to me for so many years and an extraordinary head of the Department of Chhattisgarh, and all the learned speakers, and I think most equipped with the knowledge of water, the ladies and gentlemen. In fact, I have retired about 1.5 decades ago, and during this time and during my time, there have been a lot of changes. So I will now confine to the subject theme, starting which says, towards improved urban water for sustainable development in the global south. When we say urban water for sustainable development, let us try to understand what is sustainable development. And one of the parliament session, Atal Bihari Vajpayee was the leader of opposition, and then Mr. Kamal Nath was the Minister for Environment. He spoke first time in Parliament that we had to have a sustainable development. Atal Bihari Vajpayee ji asked, please define sustainable development. The English word appears to be a very nice one, sustainable development. He used to speak in his own way. Kamal Nath ji was not able to justify and convince Mr. Atal Bihari Vajpayee. Later on, this sustainable development came in United Nations. They said it's this SDG, Sustainable Development Goal. Among there has 17 goals. And one of the goals belongs to this water sector. What is sustainable management? In Hindi कहेंगे हम कि टिकाऊ हो, और टिकाऊ हो और कब तक हो, so they have defined it that development should meet our requirement, present requirement, and should also take consideration of the future generation. But ironically, now we are facing, this generation is facing huge problem, everything that has been elaborated by my past speakers. Anyway, this is a very complex problem when India is concerned, and when the South Block is concerned. We are 140 billion. Malaysia must be about 3 billion. Similarly, Sri Lanka must be around 3 billion. Maybe Bangladesh may be about 16 billion. But we are 140 billion with multiplex and multilex problems with us, although we have all rich things with us. So my primary remarks is that how to get rid of all these problems for today, for tomorrow. Because everybody thinks of today, no tomorrow. I have written a book, Today, No Tomorrow. Means we are thinking for just now for us, not at least for my children like son, but never about grandson. So if the things are so critical now, what will happen after 30 years? So I have suggested some things out of my experience, and I think that is the only solution. So my subject for now.
So you can just use this.
Okay, it's better. Okay. My subject for now is success story, restoration of traditional water bodies in Chhattisgarh. Now, what have been said now about is something economics, effectivity, and all that. But this presentation will be confined to a success story, and let us say whether it is convincing and it is whether applicable in all over your country or no. I will speak about the traditional water bodies available in India, and that too not we are supposed to create henceforth. We have already that asset, the rich asset with us, and just I will explain you a little about the history. As long as in Treta Yuga, in say 12 lakhs years back, DB Singh Saab, 12 years back in Treta Yuga, there were 5 Sarovar. They are 4 are in our country, except Man Sarovar, which is in Tibet. Then we go to Dwapar Yuga. It is a yuga of Lord Krishna. Lord Krishna once killed a demon bull. And the Radha said, you have committed a crime. Radha ने कहा कि आपने जरा पाप किया है. तो उन लोगों ने और गोपियों ने मिलकर एक बनाया एक तालाब, कहिए पौंड, और उसका नाम रखा कृष्णा राधा कुंड. तो बोला गया कि राधा कुंड में जब तक नहीं नहाओगे तब तक तुम्हारे मियाँ बीबी का संबंध इटर्नल नहीं होगा. So that way this was constructed with the religious fact, and this still exists. Now this is AD, means after Christ. I have given only a few examples. That Hussain Sagar. I had interacted with Mr. Chandrasekhar, Hyderabadian, and Chari. This Hussain Sagar, one of the wetlands of India among 7 wetlands as recognized last, and this still is serving lot of purpose in terms of recharging, conservation, and even drinking water. And second is Uday Lake Sagar. I was just talking to Mr. Mathur, who belongs to Rajasthan. There is Sartas Sagar, that is a pond, that is a wetland, is still supplying water to Udaipur. And third is Bhostal. I think Mr. Sonargaria must be visiting every day that Bhostal. It was constructed in century 1005 and 15 by Raja Bhoj. And can you believe that during that time, without some machine like excavator and bulldozers, etc., they constructed huge, and I was in charge of the water supply of Bilaspur, Bhopal for 6 or 7 years. Half of the township was being supplied water from that very Bhostal. And Bhostal now have some renovation, and it was with the help of Japan. This was executed with my best luck successfully in 2003, and this started in 1995. So what I wanted to insist on is that this kind of reservoirs, which have been constructed by our ancestors, still work. Why are not we bothering for this? Now, what about, I'm talking of the water ponds in Chhattisgarh. if you look at this figure, you see about 2,005 acres of land was converted into a talab or pond, which we call Dalbat Sagar in Jagdalpur. Mr. Sahu had sent me a photograph. And this was constructed by 3 equipments. उसमें आगर है, कुल्हाड़ी है, और एक तसला है हिंदी में. And the lady you are seeing just on this map belongs to a community, Ramnami community. This Ramnami community had a population about 3,000 to 5,000 in Chhattisgarh. They only used to excavate and construct ponds. And they used to write all through their body Ram. And can you imagine that this Tasla and this had constructed more than 48,000 ponds in Chhattisgarh in 19,744 villages. I am trying to explain as to how during that time there was no IT, no engineering, nothing, everything. But they are only these people. This is one fort of Jodhpur, where on the fort there is a pond. And they used to conserve water, not for some small, but 3 years for the military. Still, it exists. And this man who is behind this is Gajdhar. These Gajdhars were expert in finding the sites of the ponds and wells. Gaj means Gaj liya hua. Gaj समझ रहे हैं दीपी साहब? हाँ, गज वाला, हाँ. ये गज्जर तो था, वो जहाँ कहता था यहाँ तो तालाब बना, और 2 बार पानी बरसे, with 2 rains, it used to fill up. The catchment was clear. And this way, can you believe, then one of the villages called Adbahar, क्या यार? Adbahar, 126 tanks for population of 3,000 in the year 1920, when the population, they never thought that what will happen to them. They were enough with the 2 tanks, but they constructed 126. Similar is in Ratanpur, 126. 6 कोरी और 6. 6 कोरी मतलब 20, 20 चक्का 120 और 6 126. So this is how I wanted just to make you know about what our ancestors did and how were exploited. Then we are so before going for anything, we must accept the fact and appreciate that we get enough rainfall in India. Except in Rajasthan, we almost get 1,000 millimeters of rains to 1,200 millimeters of rain, even 1,400 per annum. And one calculation I have made, which has been confirmed by Mr. Anupam Mishra, who has written a book on आज भी खरे हैं तालाब. अगर आप 1 hectare में, on a 1 hectare area, and 100 mm water fall is enough for the water demand for the village of population 2,000. 1 hectare land, if you conserve water of 100 millimeter, somehow in a different way, will be enough for the water demand for this village. This has been experimented by me as well. And one must understand also that out of 5760 hours in a year, we get rainwater only for 80 to 100 hours. And within the 80 to 100 hours, we have to catch the water. And only there is no option except to conserve, reserve, and recharge the water that falls from the rain. And third, we should take into account that we are very happy, even in this Jan Shakti Yojana, that we will supply water from underground water. The underground water is available at 1,000 feet, 1,500 feet. But it is said by our ancestors, and even sometime our Service Susariya said in one of these speeches to Mysore Assembly that water has been accumulated in Patal within 1,000 years and more than 1,000 years. And that should be used in emergency. He was drawing the capital, whereas he suggested that we should use the interest from the interest. We should not exhaust the deposit. So by pleasing everybody, government and ourselves, we are going indiscriminately for the underground water by drilling more than 1,500, 200 feet water. Then what will happen when this deposit is finished? And that is finishing. So Geological Survey says more than 300 blocks have gone critical. More than 500 blocks have gone semi-critical. And that means that is a red light, stop. But we are not stopping. In Jal Shakti Yojana, I don't know how the highest authority and the authorities are not well aware of this. If you are taking source as tubewell for Nal Jal, and we have the hilly area where the water maximum available is 1,500 gallon per hour, or even less, how will distribute it? So this is what this is theme. वैसे मैं थोड़ा time is over. अब मैं क्या बताऊं सुनगरिया साहब, हैं? Yes. अब आप ऐसा क्या करेंगे बैठ के, थोड़ा दे दीजिए समय. ये लोग ना इस युग के लोगों को बहुत गलत फहमी है कि नलकूप से पानी दे देंगे, पानी नीचे जाते जाएंगे तो साफ पानी मिलेगा. वहाँ मिलने लगा है उनको जहर, आर्सेनिक, आपको मिलेगा आयरन. आप लोग बोल नहीं पा रहे हैं ऊपर. चलिए, थैंक यू. प्लीज डोंट माइंड, मैं जल्दी खत्म करता हूँ. So ultimately the people have forgotten the importance of the traditional water bodies, and only this concrete jungle is appearing, concreted, polluted, and this big nexus between the politicians and the contractors and the government have made most of the water bodies defunct. How can you take care of this thing? So my traditional water sources, I have said ponds, lakes, wetlands, dug wells, streams, Dhondi and Jiria. You will not believe that even today we drink water from my dug well in my farm. And many of Ambikapurians are using dug well. गर्मी में पाइए तो ठंडा और ठंडा में पाइए तो गर्म पानी और खूब पानी. वो क्यों हुआ है वो बताने में बहुत समय लगेगा और सब जानते हैं. आगे छत्तीसगढ़ का जो I have said that the Chhattisgarh culture has developed around the lakes and ponds created by themselves with the sagar, not on the bank river. And they have made as many as more than 48,000 up to 68. And वहाँ पे क्या है? नहाना, धोना, खाना, पीना, शादी, विवाह, मुंडन, मरण, जीवन, सब कुछ वहाँ पे है. So I said it is a culture that developed not on the bank of the rivers, but around the ponds, lakes constructed by them during that time. Imagine. So this is what about the culture. वहाँ पे तालाबों के बीच में शादियाँ होती हैं. ये देखिए थोड़ा सा ये नज़र लगाइए. And many of the festivals including Chhat, DB Singh Sahab, you see this Chhat is only celebrated and performed. देखिए नीचे वो आके जो है ना संस्कार करके आया है, दाह संस्कार करके. So we are a study of ponds prior to 1960 में मैंने कहा है कि ये डिटेल सर्वे किया, इंक्रोचमेंट डिटेल्स लिया, उसके बाद सिटी ड्रेनेज एंटर कर रहा है वो, कैचमेंट एरिया, प्रेजेंट स्टेटस ऑफ प्लांट्स, टेम्पल्स, बैंक्स एंड हिस्ट्री ऑफ द विलेजेस. दिस आई कलेक्टेड during my tenure of 2003 to 2008 as the chief engineer and engineer chief of Chhattisgarh, and Sahuji was leading one of the teams. Then activities of restoration. सुन गया साहब, बस खाली 3 मिनट देंगे मेरे को ना, ठीक है. डिटेल सर्वे किया, removing encroachment. It is the most difficult task to remove encroachment because of the political reasons. But at the side, we have rehabilitated the people, displaced people in Raipur. In most of the tanks in Raipur, we have just created their flats, etc. nearby. I have displaced and successfully done that. And dividing, desilting, repairing of bunds, intersection of city effluent, nalas, drainage and treatment site, plantation and creation of buffer zone, provision for space for local festivals, rituals, entertainment, and provision for Dhobi Ghat, beautification and water treating facilities. These are the items that was performed in many of the over tanks, including Bhoj Lieutenant, आपके यहाँ भी, Bhopal. And I suggested Honorable Chief Minister Raman Singh in 2009 कि आप ऐसा करिए नहीं तो आपका पानी के बारे में बैलगाड़ी और टैंकर लग जाएगा. He did it, and we have been able to been very successful in that account. I have surveyed every village of 19744. What number of villages, total ponds, dug wells, jharia, and filled up in 1,000 cubic meter. This was done by my team in 3 years. And ultimately, if you see, 90,744 are total villages, 48,960 are ponds, 48,000, 60 के पहले का, and 25,500 something, 2 lakh something dug wells, 347 jharia, and 15,62,019 million cubic meter will be the volume that will be available if you desilt it. Question करिए साहब. And that will feed the whole Chhattisgarh for 1 year. And this is reckoning. But work completed around 40% to 50%. And we propose to complete it within next 4 years. These are the old tanks. These are the tanks which were polluted, concreted, encroached, and what not, everything done. And see what has been done here. On the top of it, it is a Telibanda Talab in Raipur, which we have named Marine Drive. Marine Drive. And how beautiful it looks. The colorful habitations are those who have been replaced and encroachment has been removed. DB Singh साहब, एक बार तो वाह कर दीजिए. ठीक है. नीचे देखिए विवेकानंद सागर है. These all three are from Raipur city itself, an urban area. So I insist upon that unless these water bodies are restored, regenerated and beautified, there is no solution. Advantages, you can read it. Healthy environment, employment generation. Once this is made a destination for tourists, there are at least 1,000 employment. Health place for physical exercise, place of entertainment, water conservation and ground recharging, which is more important, income generation, of course. And here you can see the other traditional bodies. You see one dug well there. Here is a stream, and there is a dhodi. I'll take much time what is dhodi, but dhodi is a whole year you get water, irrespective of drought in rural area. This is how one of the village has protected the water. So it is water saving. It is how, it is just what should be a tank. So what have I done? My initiative, I will just conclude by saying my exclusive, that I am practicing at High Court, and I am a law graduate and postgraduate as well, and had filed a BIL praying to direct the state government, that they should make a plan for restoration, regeneration and beautification of ponds within 10 years. And then also, they must be directed to report the progress to the registrar. So they have made this direction to the state government, and they are still directed that to introduce a bill, water sustainability bill. They promised, but they are yet to introduce in Vidhan Sabha. With this, I conclude my address, and will take pardon from the chair. I have taken a lot of time. Thank you so much.
Thank you, sir. Thank you very much. You have very nicely presented the journey of our traditional water sources. आपने भोपाल का जिक्र किया. भोपाल के बारे में कहते हैं ताल में ताल, भोपाल की ताल, बाकी सब तलैया. So with this note, I would like now to request Shri Sudhakar N. Handeji, who is an Executive Engineer, Water Supply Project Department, MCGB, Mumbai.
Good evening, everybody. It is a case study that we have. This study is in planning stage because Mumbai's water supply is the very unique water supply all over the India, or you can say in world also, because daily we are supplying at around 4,000 million liter water to the Mumbai city, and this water, 96% water, is conveyed from the 140 to 100 kilometer from the Mumbai city. There is no inherent water bodies available in the Mumbai city. Mainly, we are the first corporation we are the owner of the 6 major dams we have constructed, mainly in Vaitarna Basin and the Bhatsa Basin. And major dam is Vaitarna Dam, Middle Vaitarna Dam and Modak Sagar Dam. And this water is from these dams, we are supplying water to the Mumbai from at around 140 kilometers away. Now, everyone knows that now developing a new sources of the water supply schemes are very difficult due to the very environmental challenges, local issues, and many other aspects that project may delay or may abandon also. So this is the small presentation that I'm going to present here for what type of now sources we are developing by small things, by constructing a small thing all over our existing water network. We are supplying water from, these are the sources that you can see: Upper Vaitarna Dam, Middle Vaitarna Dam, Modak Sagar Dam. These 3 dams are on the same river, that is the Vaitarna River, and we get the waters from this. These are the storage reservoirs. In monsoon season, fortunately we are having a good catchment area and good rainfall area. That's why we get the catchment and the capacity that we require for the Mumbai city. These are the project background. It is now we are initial stage. We are working on this proposal that how much water in this basin we can get additionally without disturbing the environment, without disturbing the land acquisition issues, environmental issues. Because I have to go fast. No, I have time, no? Because the water supply is very vast, we cannot come back. Yeah. These are the main sources of the Mumbai city: Tulsi, 18 MLD, Tulsi and Vihar, Tulsi and Vihar, only 18 and 110 million liters. That is at around 3% water we get from the Mumbai, inherent of the Mumbai city. Remaining water we have to convey from the hundred of kilometers from the Mumbai city. Now we are investing and we are working that how we can, within this networking, with the existing network, we can enhance our the water sources for the Mumbai city. Our dam is, we are getting the water Upper Vaitarna, Modak Sagar and, Upper Vaitarna, Middle Vaitarna and Modak Sagar. These 3 dams are in series. We release the water from Vaitarna Dam to Modak Sagar, Middle Vaitarna Dam and Middle Vaitarna Dam to Modak Sagar Dam. There is the free-flowing rivers. between free-flowing river between Upper Vaitana to Middle Vaitana and Middle Vaitana to Modak Sagar. And we are now we are now in planning stage. How we can get the water, additional water, by constructing the check dams in between two reservoirs, so that we can without disturbing the hydraulics, without disturbing the environment, without disturbing the land acquisition issues. So in between Middle Vaitana Dam and Upper Vaitana Dam, we have just in planning stage to construct 3 numbers of dams, we can get 25 million of liter water from Modak Sagar Dam to Middle Vaitana Dam on the same river, by constructing the 16 number of check dams, small dams, and we will can get the water at around 45 million liters of the water. From the downstream of the Modak Sagar, that is the free flowing river, that overflow gets that is overflow, and it's merged into the sea, Arabian Sea. Then after, we are also having a Tansa Dam. Same proposal we are working on that. That also we can get at around 50 million liter water per day. That are and investing the other dams, that is subsidiaries of this catchment area. Total we can get at around 300 million million liter water per day with our existing network and with the existing resources, without disturbing anything. This is the map. That is, there are 4 proposals. We are working on that. Proposal 1, Proposal 2. Proposal 1 is, that is what that I have told, that Vaitana to Upper Middle Vaitana to Modak Sagar. Proposal 2 is for Tansa Dam. Proposal 3 is for Batsa Dam. And Proposal 4 is for the subsidiaries in the catchment area of these all dams. These are the key map. Upper Vaitana Dam, Middle Vaitana Dam, Modak Sagar Dam. These are Tansa is only the dam. Then the Batsa Dam. These are the proposals. In Proposal 1, between Middle Vaitana to Upper Vaitana, 3 check dams we can construct. We can get capacity of around 25 million liter. It's a huge capacity. It is not a small capacity, but Mumbai, it is a small capacity. But then also we are now in planning how can we can in future we can sustain for at least 15 to 20 days for the last season of this summer. Upper Vaitana Dam, Middle Vaitana, that you can see. These are the location plan. And we are planning to construct these in between Middle Vaitana to Upper Vaitana, 3 dams. Vaitana to Modak Sagar, 16 dams. These check dams, we are also identified the tentative locations. You can see the tentative locations of these dams, check dams. 3 dams, we have one at 2.2, 2.82, and 2 million liter, total 7.02. The MCQ, this is MCQ, and it is at around 25 million liter per day. These are the locations. This is Upper Vaitana to Middle Vaitana. 1, 2, 3, you can see. These are the same. It is a Google image. This is also the actual photographs. Proposal 2 is in between Modak Sagar to Middle Vaitana Dam. We can get by constructing the 16 number of small check dams, we can get 45 MLD water per day to the Mumbai. This is a huge capacity that it can cater for the small city also. This is the Middle Vaitana Dam and the Modak Sagar Dam. In between we have, these are the spots you can see. These spots are we are proposing there these small check dams. Yes. These are the this small 16 number of that this is the capacity we have shown here. Same. Proposal 3, downstream of the Modak Sagar, that waters, there is a discharge of the water directly goes to the, this is the wastage, goes to the directly Arabian Sea. The 36 MLD water we can capture and supply to the Mumbai city. These are the locations that we are planning to construct the check dams here. These are the images. This is a proposal at a glance. Proposal number 1, 2, 3, 4. Downstream of the Tansa dam also we can get by constructing 9 numbers of small check dams without land acquisition, without environmental issues. This is 50 MLD water we can get. These are the locations at what we are understanding. And they are subsidiaries of the Vaitana and Bhatsa rivers. We can capture 143 million liters of the water level. These are the locations. These location, this type of dams, check dams, we are going to construct with proper automation. Current demand up to 50 MLD. There are 5 proposals we are in NasikSeva. We are planning on this without disturbing. This is the economy. This is the economical proposal. We can recharge surrounding surrounding water table also, and these water can be used by the villagers of these river banks in probably in winter summer season. $300 MLD water is the big water supply, because we are now planning to construct one Garge dam at around 450 million liter. Apart from this, we can, without any land acquisition, without environmental, without tree cutting, without land acquisition, we are planning to capture 300 MLD additional water to the Mumbai city. It is a very short time, because Mumbai's water supply is very huge and it required very huge time. Thank you very much.
Thank you very much, Sudhakar ji, for your very nice presentation on the Mumbai water supply scheme, the capital, commercial capital of our country, and about the 5 new projects or proposals for additional 300 MLD of water to be stored for the water supply for the city of Mumbai. I would not like to invite any questions, if any, from the people sitting over here. No question? Then I would like to request Sri Parag ji to continue. Next. Yes.
So my question is to Mr. Hande sir. Can you just elaborate inflated rubber technology which you are going to use in this construction of check dams?
We are planning.
You are planning?
We are planning, but right now decided.
Okay.
We are exploring how can it be automation, or without automation, without electricity, or with electricity, or conventional type.
Okay.
Thank you, sir. So after completion of these 6 sessions, I request Ramesh Wambre sir to felicitate the chairman of this session, Songaria sir. I request Srivastav sir to felicitate the speakers of this session. Our past president, Mr. R.N. Gupta sir. Sir. Shri Ajay Sahu sir. Aram se. Dr. Ravi Kumar Joseph sir. Thank you, sir. I request Mr. Badgujar to felicitate Sri Sudhakar Hande, sir. Thank you, sir. And after 5 minutes only, we are going to start the valedictory session immediately. Thank you, sir.
You are very much on time.
Yes.
Immediately. Every celebration is an experience. The external fades away and the internal echoes in the most depth of our hearts. We are reminded that events like this one are milestones on the journey of life and reminders of God's fidelity all through. It gives me immense privilege to invite and request the chairman, convener, and co-convener to kindly accompany the guests, the chief guest and guests of honor on the stage, and to honor the dais. I request you to kindly ascend on the stage with Dr. Parag Sadgir, Director International IWA and HOD Department of Civil Engineering, COEP Technological Institute, Mr. Dhaval Patil, General Manager, EcoSan Services Foundation, Conference at a Glance Way Forward, Mr. M. Mathia Lagan, Vice President IWA, Mr. Subhash B. Bhujbal, President IWA, Mr. Chakradhar Hiralal Kandalkar, Deputy Municipal Commissioner, Special Engineering, Municipal Corporation of Greater Mumbai, Dr. Ashok Karanskar, IAS Commissioner and Administrator, Nashik Municipal Corporation, and Dr. Dayanand Panse, Director Utility, Iowa. I welcome all of you on this dais. I also request Mr. Nandakumar Jagtap to kindly honor the dais and Mr. B.K. Parida to be there on the stage to do the honors. So, yes, let's welcome all the dignitaries on the stage with a wonderful floral welcome. So first of all, I request Mr. Anant Nampurkar to felicitate and welcome Mr. Chakradhar H. Kandalkar, Deputy Municipal Commissioner, Special Engineering, Municipal Corporation of Greater Mumbai. We welcome you to this international conference, sir. After this, may I once again request Mr. Anant Nampurkar to kindly welcome Mr. Nandakishore Jagtap, Chief Engineer, Pune Municipal Corporation, with a flower. Next, may I call upon Mr. C.R. Gajbiye to welcome Mr. Subhash B. Bhujbal, President, Iowa, with a lovely bouquet. May I now call upon Mrs. Vaishali Patil to come ahead and welcome Mr. Dhaval Patil, General Manager, Ecosan Services Foundation. Next, I call upon Mr. Ramesh Bamble to welcome Mr. B.K. Parida. After this, I request Ms. Radhika Borgaonkar to welcome Dr. Parag Sadgir with a lovely bouquet. I once again request Ms. Radhika Borgaonkar to welcome Dr. Dayanand Panse, Director Utility, IWWA, with a lovely bouquet of flowers. Thank you so much. We once again welcome all the dignitaries. Now may I call upon Dr. Parag Sadgir, Director, International IWWA, to kindly come ahead and welcome the dignitaries.
Thank you. So, after the 2 days and 6 sessions, in which we have covered total 28 topics by the various speakers from South Global, and that is the South Africa, Nepal, and Malaysia, and Thailand. So total 5 presentations, which are, and other presentations from India, various parts of the India. And we have discussed on various themes which are related with these particular water sector, and brainstorming sessions were conducted for these 2 sessions and 2 days. And now we are coming for the concluding session. So now I welcome all the dignitaries on the dais for this session, and thank you.
Thank you, sir. I'm sure all of you believe that this conference has really been a fruitful one. It was really a very informative and engaging conference. And I would now call upon Mr. Dhaval Patil, General Manager, Ecosan Services Foundation, for the conference at a glance and way forward.
Thank you. Yeah, it's a little difficult task to sum up the 2 days. We had a lot of discussions. We had a lot of great speakers and experts and practitioners from the water and wastewater field. But still, I'll try my best to cover the points and the sessions which were made during the different talks. So yesterday, the first session started with water conservation and demand management, where there were several speakers, but yeah, the ones which I recollect, Mr. Madhavan, he talked about various aspects of water management, starting with hope, concern, and desire. So what are the hopes for humankind? Then the concerns like groundwater management, water quality management, and financial viability, and the desires as to how the utility management needs to be, how the autonomy and efficiency is expected in these utility management, and of course, circular economy. We also saw a great presentation from Mr. Maniam, who represented India Water Works Association. He focused on how India Water Works as an organization is running the utility services for the country of Malaysia. And he showed how the country has planned until 2040 in a phase-wise manner, sort of pinpointing at all the bottlenecks which the country is facing, right from engagement with the stakeholders to how to increase the tariff in an incremental manner, plus introducing new concepts of circular economy. In the end, he also sort of presented the new interventions which their company is doing by showcasing that they are trying to do sewage sludge management by making biochar out of it. biogas generation by co-digestion of the food waste and the sewage sludge. An interesting slide he presented about black soldier flies, and also how the biosolids, basically the end product of sewage sludge, can be used as biofertilizer, and how that can bring out a lot of revenue. The next session was on water quality aspects, wastewater management and resource recovery. In this session, Mr. Uday Shankar Prasad, he sort of put forward WaterAid's journey of how monitoring of water sources is being done. He sort of pinpointed at the fact that transparency in the system is very important, especially when we are dealing with the quality of drinking water. And he put forward a very interesting idea of how crowdsourcing framework can help to sort of rapidly improve and ensure that the water quality is maintained throughout its journey. Ms. Isha Basial, she presented about city-wide inclusive sanitation and sort of put forward an idea where sewered and non-sewered sanitation both needs to be into coexistence for the city to sort of manage its wastewater and liquid waste. A very interesting sort of quote I remember she made in her presentation, that 56% of the benefits from subsidies, they are going to only 20% richest population, 20% richest population in India. And that, not in India, sorry, in the world. And that is what is really alarming. So we as practitioners need to focus on how we introduce these subsidy schemes into the larger programs, so that the real beneficiaries, the pro-poor economy, pro-poor population gets benefited out of it. There was a presentation by Dr. Dole, who presented wastewater management in the Kathmandu Valley. And in his presentation, he made a point about tailoring governance arrangements to address the challenges and need of the population in the valley. Then we had an interesting presentation by Mr. Raut, who presented wastewater management and reuse, and how the resource recovery and reuse can be a win-win for the public as well as the private entities. And this process might also address the water security challenges which we are facing, or most of the Indian towns are facing. Mr. Balaji from Larsen and Toubro, he presented about water management, water quality, urban utility management, and sort of introduced the audience to something called digital twin, on which subsequent speakers focused more. Just to sort of summarize what he said about digital twin, it was more about application of artificial intelligence in hydraulic analysis for improving the utility management. The third session was on effective operation and maintenance of utility assets. And in that, Mr. Bockhoff from Suez, he presented a little in depth about the journey of digitalization which they have taken, and how it is important to use these tools, not just to digitize, but digitalize the systems to improve the utility services. Dr. Satyanarayana, he took us through the journey of Hyderabad Metropolitan Water Supply and Sewerage Board, and two of the things which I vividly remember from his presentation, where the one of it was an app called Jal app, Jaldi Action Law, which was sort of a water quality complaint redressal app. And the other one was Nayanta app, which also sort of addressed the water quality issues. It was more on the crowdsourcing, which Dr. Uday had spoken before. And then, yes, Mr. Sharma, he presented he was from Bentley, and he presented about digital twin for planning, designing, construction, and operation and maintenance of the utility services. Day 2, that is session 4, started with circular economy for strengthening urban water management. We kicked off with an amazing speaker, Mr. Vishwanath, who took us to the town of Devanhalli and a water body in Devanhalli, which is very important, and how his company sort of used the treated wastewater to revive the lake. Not just that, he also showed how integrating the shallow aquifer for improving the water supply for the town of Devanhalli could help improve the access to safe drinking water. Mr. Dipinder Kapoor, he presented on circular economy for what and for whom. It was interesting because he talked about centralized, decentralized, seaward and non-seaward sanitation. In his presentation, he also showed how the city can be covered through seaward and non-seaward sanitation systems. And he mostly spoke about the research and publications of Center for Science and Environment on biosolids and performance assessment of FSTPs. Mr. Savdi, his presentation was really simple and straightforward. And one slide I remember from his presentation was, we need to start, as practitioners, we need to start thinking about wash basin to river basin. So we need to take into consideration the full cycle of urban water. And he presented a case study on wastewater reuse in thermal power plants, and also he spoke about introducing a pilot project in their Kolaba project for producing potable water quality. Next was a presentation from Mr. Zadav from WS2 EPL, which showed the packaged drinking water treatment plant. It was fascinating for me as well, and I believe for most of you, to see how a MLD scale design plant can be sort of compacted and packaged in a smaller way so that it can be easily transported and implemented in a very short duration of time. Mr. Sagar took us to the journey of Maharashtra Urban Wash Environmental Sanitation Coalition work. He talked about urban-rural linkages, which is Maharashtra state's government right now one of the foremost objective, as to how the urban utility services can be extended to the rural parts of Maharashtra. He also spoke about one research study done on the same topic, and about the refurbishment of a fecal sludge treatment plant in Indapur Council, and a co-treatment of fecal sludge and septage at an STP of Sangli city. Mr. Sawant spoke about the role of water in biosphere, and he covered a lot of different, he brought a lot of different perspective towards water during his presentation. Session 5 was on climate change and adaptation, where Mr. Azuan from India Water Works talked about how the company is managing tariff for water supply and sewerage management, the challenges which they are facing in sort of recovering the cost of maintaining these services, what are the steps involved while planning for stakeholder engagement, and the strategy and implementation of their company. He also presented how a database called eKasi is being used to improve, continuously improve their services to the population of Malaysia. Professor Vyas presented a very interesting case of how artificial intelligence and machine learning solutions can help to design more climate resilient urban water technologies. And definitely she sort of gave us a future of how AI/ML can help us to sort of improve upon the design and operations of water and wastewater utility services. Dr. Zugdev from International Water Association presented more about the association and their activities which they carry out. Dr. Singh talked about climate change and its impact. There was some interesting slides on GHG emissions, which I personally liked very much. That too linked with seaward and non-seaward sanitation. It was an interesting comparison to see. He also presented about a way forward for building resilient systems. Dr. Labasitwar presented about climate change and its impact, mainly on water scarcity and water quality. He presented few case studies from the state of Maharashtra, from district of Latur and Nagpur as well, which were pertinent to the topic of the session. And this brings us to the last session, session 6, on socio-economic aspects of water management. In this session, Mr. Ravi started with urban sanitation services, how important they are to sustain the functionality of the city. He talked about access to toilet, and not just access to toilet, but access to toilet among different socio-economic classes, which is very important. He also talked about, say, if you need to sustain the system and its functionality, then sanitation workers' safety is pertinent. Next was Mr. Sahu, who talked about the flagship programs of Jal Jeevan and Amrut 2.0. An interesting phrase he used, doubling farmers' income, which I really liked, because that is a sort of outcome which the program should have. Because when we are talking about basically doubling farmers' income, indirectly we are talking about water security and food security. So it's an interesting outcome to have for bigger programs. Also, he focused more on groundwater management and talked about Atal Bhujal Yojana and about specific actions or interventions to be taken for groundwater management. Mr. Gupta, I really liked his slides pertaining to Chhattisgarh and how the indigenous traditional ways of water management were being done in India. Conserve, reserve, and recharge of rainwater was his message. He also gave insights into the social aspects of water management in the state of Chhattisgarh, from where he belongs. And he concluded his presentation with the study of ponds and his findings, and also the restoration of the water bodies. And that brings me to the last presentation by Mr. Hande. He presented a case study of economic analysis of existing water resources in Mumbai and how the city officials of MCGM are planning to cater to the water demand of the mega city Mumbai. So thank you, and this was the summary of the 2 days. Yeah, sorry, I need to also present the way forward. And yes, I feel a lot of interesting discussions have happened in 2 days, and we learned about a lot of new things, especially artificial intelligence and machine learning is something which we are at a very nascent stage. We, in the sense, India is at a very nascent stage. And I believe we are sitting on a gold mine of database right now. India, if you see, with its huge population, is creating a lot of data every day. And in mostly sewerage and water supply and water and wastewater treatment facilities which India is setting up, we see everywhere SCADA is being implemented. And SCADA is, as we know, not only sort of records the data, but also helps to utilize that data. And that is where the future lies. So I'm sure the way forward for the utility services is to not only digitize, but digitalize the system, and also sort of, for the lack of better word, exploit the data which India is generating. Thank you.
Thank you so much, sir, for summing up the whole 2-day conference just in a few minutes and for the way forward. Next. I've heard somewhere, a pessimist complains about the wind, an optimist tries to change it, but a leader adjusts its sails. The sails for this particular motion were adjusted by a person who's not only a great motivation to all of us, but a visionary and the person who gave us the belief to bring together this conference. He is none other than the President, Mr. Subhash Bhujbal. May I take the pleasure of requesting him to address the gathering.
Chief guest of this valedictory function of International Conference, Mr. Chakradhar Kandalkar, Deputy Municipal Commissioner, Special Engineering, Municipal Corporation of Greater Mumbai. Guest of honor, Mr. Nandakumar Jagtap, Chief Engineer, Pune Municipal Corporation. Honorary Secretary General, IWWA, Sri Paridaji. Dr. Dayanand Panse, Convener and Director Utility, IWA. Dr. Parag Satkir, Co-Convener and Director International, IWA. Mr. Dhaval Patil, dignitaries on the dais, respected past president, respected council member, fellow delegates, ladies and gentlemen. Good afternoon and welcome to the valedictory function. As we are close to the end of this 2 days international conference on a theme towards improved urban water for sustainable development in the global south, I'm happy that the event is very well received by one and all. This is one of the events I was committed to when I took over the presidency of this esteemed organization, Indian Waterworks Association, in the month of January 2023. Conducting any event is a teamwork and needs contribution and support of many individuals and agencies. While planning this conference, we considered various venues such as Mumbai and Pune. However, ultimately we settled on Nashik. One of the reasons selecting Nashik is the infrastructure available at MITRA, that is Maharashtra Environmental Engineering Training and Research Academy. Just now I was talking to Songria sir about the conference, and he even felt that holding conference in such a venue instead of hotel, it gives feel of institute, feel of college, and it becomes more appropriate venue for such kind of events. Like that, everyone present here must have found the premises of Mitra very green and refreshing. In fact, the state-of-art hall we are sitting in took the experience of presentation and listening to the different level. The hostel of the Mitra is also very good. I hope the delegates who stayed in the hostel must have pleasant stay. And as far as support, any event needs support, it needs funds. So I'm happy to share that we received support from 26 sponsors. We can see here diamond sponsors as well as silver sponsors and few advertisers. So there are two sponsors I would like to thank to NGS and L&T. There are 9 gold sponsors listed here. I would like to thank all of them. Silver sponsor, 15 numbers listed there. Again, social dinner that everyone enjoyed yesterday, it was supported by Mrs. Vilas Jagtap and Mrs. Vihan Construction. I would like to thank them. I express my gratitude towards all the sponsors for supporting us. I would also like to thank the exhibitors and advertisers. Within a very small period of time, we could collect the funds for this conference only because of wholehearted support by all of these people. I would like to appreciate the efforts taken by Sri Panse, Director Utility, IWA, to organize this conference. We had a wonderful session, very good speakers. Sri Panseji took lots of effort for that. And he was ably supported by Professor Dr. Sadgir in organizing this conference as a co-convener. I would like to appreciate the efforts taken by Mr. K.N. Pate from Pune Center, handling nicely the accommodation, travel arrangement, and com-meeting of IWA. I would like to appreciate the efforts taken by Sri Nampurkar, youngest and very lively member of Pune Center, who took care of exhibition and dining and everything nobody is looking after. Miss Radhika Burgaonkar and EcoScience team working tirelessly since last few days. Thank you, Radhika and team. There are many people behind success of any event. I'm not able to take all the names. However, I would like to mention few. I acknowledge and appreciate the support provided by Mrs. Sunanda Narwade Madam, Director Mitra, Mrs. Mawa Banerjee, Deputy Director Mitra, Mrs. Vaishali Auti, Vice Chairman IWA Pune Center, Mrs. Vaishali Patil, Assistant Engineer, Chief Engineer Office, Nashik, all my engineers of Nashik region, Member Secretary MJP, Principal Secretary Water Supply and Sanitation Department, Government of Maharashtra, Jal Shakti Ministry, Government of India, office bearers of IWA, COM of IWA. This is not a vote of thanks, but as organizer of this conference, I would like to thank all these agencies and individuals. For the conference, we invited very good speakers from India and abroad. I'm sure delegates must have enjoyed all the sessions. During the course of event, IWA and IWA, International Water Association, had some discussions for taking forward the association between IWA and IWWA. CEO of IWWA Malaysia offered IWA delegation to visit facilities of IWWA in the Malaysia. We look forward to that. I believe all of you have a very good stay in Nashik and wonderful conference. Thank you very much for attending in big numbers. Thank you. Thank you once again.
Thank you, sir. The fragrance of flowers spread only in the direction of the wind, but the goodness of a person spreads in all directions. Ladies and gentlemen, we are delighted to have Mr. Kishore Jagtap, Chief Engineer, Pune Municipal Corporation, as the guest of honor of the valedictory ceremony. I'd like to call upon him to share his views with this conference with this audience.
Ladies and gentlemen, good afternoon all. With due respect to learned dignitaries and learned delegates, I would like to thank you all, my colleagues, which are present for this international conference on towards improved water for sustainable development in Global South. Basically, I am a civil engineer working with Pune Municipal Corporation in capacity of chief engineer in the water supply department. We are implementing equitable and 24/7 water supply project for Pan City of the Pune city. As we conclude this enriching 2 days international conference on water and wastewater management, I extend heartfelt gratitude to esteemed speakers, sponsors, participants, and organizers. Your invaluable contribution have made this event grand success with the knowledge exchange and collaboration in addressing crucial challenges. Let us carry forward insight gain to create sustainable future for water management. Thank you for all your unwavering commitment and enthusiasm. Wish you all a great day ahead. Thank you.
Thank you, sir. Nothing great will be achieved without great men, and men are only great if they are determined to do so. Ladies and gentlemen, we are happy to have with us Mr. Chakradhar H. Kandalkar, Deputy Municipal Commissioner, Special Engineering, Municipal Corporation of Greater Mumbai, as the chief guest. May I kindly request him to share a few words with all of us.
Guest of honor, Nandakumar Jagtap sir, President IWA, Bhujbal sir, Parag Sadgir sir, Panse sir, Pereira sir, and Dhaval Patil. And all sitting on the dais, a very good afternoon and warm welcome to all of you to this valedictory session of the International Conference on toward improved urban water and sustainable development in Global South. Over the last 2 days, we have deep insight into several issues related to water, water conservation, water quality, wastewater management, resource recovery, effective operation and maintenance for utility asset management, climate change adoption and resilience, innovative technology capacity building, and socio-economic aspect of water management. Water is one of the most important resources for the basis of life for every living organization. Water is foundation, life, and livelihood to the sustainable development. There is an urgent need to address the emerging water crisis of urban water supply, wastewater and stormwater management in global south. All the people, whatever their stage of development, social economic conditions, have right to have access to drinking water in quality and quantity equal to their basic need. The water demand is increasing day by day. There is an imminent need to deepen our understanding of our water resources and uses intervention that make our water use efficient and sustainable. Such sessions help in finding the solutions for such things. SD6 goal of World Bank is to ensure the availability and sustainable management of water and sanitation for all. By 2015, close to 70% of population will be living in the cities compared to 50% today. Globally, 80% of wastewater generated by the societies flows back into the ecosystem without being treated. The opportunities from existing wastewater as a resource of water are enormous and need to be identified and brought into the reality. Beyond meeting basic need, resource is article to sustainable development for agriculture and even industrial use. Water utilities play a crucial role in providing safe, reliable water services to the community. They also involve maintaining the infrastructure system necessary for delivering high quality water while safeguarding public health and environment. Smart utilities have potential to transform the way we manage our infrastructure and ensure sustainable, efficient, and equitable access to clean drinking water. Smart technology coupled with the skilled workforce can ensure a more sustainable future water resources and benefit from improved customer services, increased resilience, greater efficiency, and saving in cost. Water conservation, crucial for sustainability, encourages water saving practices to decrease the consumption, protect our finite resources. This includes fixing leaky faucet to prevent the water wastage, installing water efficient appliances that optimizes the use, conducting water audit to understand and rectify the wasteful practices. Each action, however minor, contributes substantially to cumulative conservation effort, safeguarding water resources for future generations. Water pricing is also an effective tool for efficient water uses. Suppose telescopic tariff is applied or encouraged, will encourage to adopt the water saving habits, potentially reducing the water bill. Efficient water uses can enhance the overall water supply, mitigating water scarcity issues. Water reuse and recycling is an innovative strategy that maximizes the water utility by treating and repurposing treated water for various purposes such as flushing purpose, industrial use, and irrigation. This not only conserves the water but also reduces the new water demand. Water governance relates to the enabling environment in which the water management action takes place. Effective water governance promotes responsible action and measures to optimize the services benefit obtained from those resources. According to estimate, India has 16% of the world population, but only 4% of the freshwater resources. Despite significant investment and improvement in the water sector, it is becoming very difficult to manage ever increasing demand, particularly with the growth of the cities and urbanization. Drinking water demand is increasing in urban area. This is not only due to increase in the population, but due to upliftment of the life of the people, change in lifestyle. Suppose if slum is developed, then they goes into the buildings. Naturally, their demand increases. Means not only the population pressure is there, lifestyle pressure is also on the increase in the demand. Further, policies are required to be such that all the sectors of the society shall have easy and access to required water, whether rich, poor, or different socio-economic level. Right policies of water governance help in socio-economic development of a society as a whole. Wastewater management and resource recovery based on a circular economy not only improves the sanitation, it has also economic benefit and reduce environment impact. Asset management for water utility is more complex than the other sector because the number, variety, age, and location difficulty in inspecting and maintaining the water asset, mostly pipelines, etc., are buried in nature. Asset management program with good data, including asset attribute, that is age, condition, criticality, life cycle closing, proactive operation and maintenance, and capital replacement based on the cost-benefit analysis can most efficient method to meet the challenges. Proper asset management help in prolonging the life of asset, decision about repair, replacement, rehabilitation, system sustainability, and financial planning. Asset management is the process where the planned maintenance can be conducted and capital assets, suppose pumps, then motors or pipe, whatever it may be, can be replaced or upgraded in type so that water supply system and infrastructure can be maintained properly. Proper asset management also involves planning and budgeting the critical activity, sustained performance, improving responses to emergency, improving security and safety of asset, and reducing the cost of operation and maintenance. Integrated water resource management system have based on past integrated management system have based on the analysis and historical climate data and hydrological data. However, future changes in the climate no longer allow such assumption. The changing frequency and intensity of droughts, floods, precipitation, heat wave have particularly significant impact on water supply and demand. The activities that enhance the water supply include increasing users' access to conventional water sources, improving management of these resources, rehabilitating natural habitat, improving dam operation, reusing drain water, wastewater, transferring the water from one river basin to other river basin, increasing will lead to increasing destination of water reach, and controlling the water will also help in controlling the water pollution. Climate change adoption at higher level will involve combination of policy adjustment and investment in infrastructure and management, improving storage capacity of the dam, river protections, these are also included in that. Resilience coping strategies are those have the potential to reasonably effective under largest positive range of scenario, means drought and maximum rain. That system should sustain in the both the ways. Complicated with the adaptive management of existing and future water infrastructure. Improving the resilience and water infrastructure to withstand climate change related shocks and extreme event is a vital part of any effective water management planning. Use of advanced innovation in technology need to be adopted. Smart water management uses advanced technologies such as sensor, data analysis, artificial intelligence to optimize the use of water. Smart water management can help in detect leak, minor water quality, forecast water demand, provide real-time use. It can also enhance the water conservation, reduce the energy conservation, and enhance resilience, water-related risks. Technique to ensure the sustainable future include water harvesting, desalination, use of renewable energy, water reuse, and smart water management have potential to transform the way we use our water. Also, the capacity building, institutional capacity building is very important. the framing right kind of policies, crafting the right kind of rule and regulation, fostering needed changes in the institution, organizational changes for water allocation and water resources are the key. Other factor is building the professional team with the skill personals who can provide the research, expert input, etc. are the key to the capacity building in the institution. Water is one of the many factors for socio-economic development. Water fulfill an economical and social, cultural, political and ecological role in improving the quality of people's life. For example, if the dams are constructed, it has very potential. It can serve irrigation, it can serve water supply, it can even develop as a tourism spot which will help in developing the local economy and this thing. Circular economy is an innovative approach to water management that mimics the natural water cycle by closing the loop on water use and reducing the waste. This approach focuses on maximizing the use of water resources and reducing impact on environment. Population growth, customization, and climate change place increased pressure on water resources. New approaches must need to be developed to manage the water more efficiently and effectively and sustainably, where circular economy come in picture. One of the critical component of circular economy is water resource recovery. This involves treating wastewater and other water sources to remove the contaminant, restore water quality so that it can be reused. This helps in conserving water resources and reduces the need of sources. Reducing it also helps in reducing the environmental impact of water extraction. The circular economy is an innovative approach to water management, maximizes the water resources, reduces the waste and improves the water resiliency through collaboration, innovative solution and sustainable future. The implementation of circular economy in water and wastewater is need of our. As a corporation, we are planning this sewage treatment plant. One of the NGOs might have given in their presentation that Bombay Municipal Corporation has going for advanced tertiary treatment for 12 MLD plant, which can be that water will be as good as that of potable quality. This is our small initiative, and again Mumbai is having constructing 7 WTPs. Nearly 2,600 MLD of water, wastewater will be treated. Set our mindset that water resilience policy. We are going for desalination plant. Means that nearly 400. Chennai, I think that they have already done that because they have source of. And Mumbai is fortunate that we have 2 basins. One is Upper Vaitarna Basin and Upper Vaitarna Basin. Oh, sorry. One is Vaitarna Basin and one is Bhadsa Basin. And there are climate change there is no effect of the climate change as such as large. Even during even this year, we also got nearly 100% dam filled with the water. That is the that is unique situation. Sometimes one basin fail, but other also get generated. My colleague Mr. Hande has given the presentation. Whatever surplus water that is going to the sea after though we have constructed 3 dams, Upper Vaitarna, Vaitarna and Middle Vaitarna and Vaitarna. Still there is a surplus water nearly say 300 million liter per day. That can be stored like by constructing a check dam, which will not even submerge the sea area. It will site selection is planned in such a way that It will not go beyond the high flood level of the river during the flood situation, so that there will be no environmental impact of this. Means these are the thinkings. Even means recycle for cities, particularly global north have even European global north or European or developed country, they have already gone for this water recycle economy. But south, it is a challenge because of the cost, means price to that. But we will have to adopt and see that how sustainable and economical solutions can be in future for this water solutions. Thank you very much.
Thank you, sir, for your words of wisdom and enthusiastic remarks. It has been a pleasure for all of us to listen to you. It has indeed been a privilege for all of us to have all of you at this magnificent conference. We express our deep and heartfelt gratitude and display our sincere respect for you in the form of beautiful mementos. So now may I call upon Mr. Anant Nampurkar to kindly come on the stage and felicitate our chief guest, Mr. Chakradhar H. Kandalkar, Deputy Municipal Commissioner, Special Engineering, Municipal Corporation of Greater Mumbai.
This Diwali, gift yourself a
Thank you, sir. I once again request Mr. Anand Nampurkar to kindly felicitate Mr. Nandkishore Jagtap, Chief Engineer, Pune Municipal Corporation. Next, may I call upon Mr. C.R. Gajbiye to felicitate Mr. Subhash B. Bhujbal, President, IWWA. Thank you, sir. May I now request Mrs. Vaishali Patil to please come ahead and felicitate Mr. Dhaval Patil, General Manager, EcoSense Services Foundation. I take this opportunity to invite Mr. Ramesh Bamble on the stage to felicitate Mr. B.K. Parida. After this, I call upon Ms. Radhika Borgaonkar to felicitate Dr. Parag Sadgir, Director, International, IWWA. I once again request Ms. Radhika Borgaonkar to felicitate Dr. Dayanand Panse, Director, Utility, IWWA. Thank you, ma'am. On this note, let's conclude a remarkable, memorable, and knowledgeable valedictory session. END, that is END. It's actually, I don't think it's an end, but I feel it's literally, it means effort never dies. IWWA, along with all of you and the support of the speakers across the global south, have taken a lot of effort towards this magnificent conference, towards improved urban water for sustainable development in the global south. I consider this as one of the initial steps, and I'm sure there's a better future with this galaxy of intellectuals like all of you. So I request the Director, Utility, IWWA, to please come ahead, Dr. Dayanand Panse, and propose the vote of thanks.
Thank you. I really like the quote, effort never dies. And And of course, I also believe that the events like this should not come to an end. But then event is an event which is of a finite time. So here we are at the end of this beautiful 2 days conference. The respected chief guest of today's voluntary function, Sri Kandalkar sir, guest of honor Sri Jagtap sir, Honorable President Bhujbal Sahib, B.K. Parida ji, Dhawal and Sadgir sir. Let me remain indebted to all of you and to all of us also who have been supporting this event for last 4-5 months, rather than simply say thank you and goodbye to all. So that should not be the custom. So, but then, yeah, we are really thankful to all of you for last 4-5 months hard work. This hard work is a collective effort of different teams, IWWA as well, Team VSF spearheaded by Radhika and supported and guided by Dhaval and Saurabh, and of course supported by Sandeep and Bhakti and Shivani and all. Yeah, your hard work has really paid for that, and yeah, we are here with these beautiful results. The event of this magnitude cannot be successful, and our heartful thanks to all the support given by Mitra. Before that, I must thank the Honorable Minister, Sri Gulab Raoji Patil, who could not be here, but then he had given his best wishes. And of course, the Minister of Sri Lanka, he also had tried his level best to get connected, but because of some connectivity issue, he could not deliver his speech. So, had it been, then we could have definitely heard his views, and those views were really from the global south. Excellent work compiled by Mr. Chaure of Souvenir, and that has really come out nicely. All the contributions by the authors in the form of article, that's one of the feature of this Souvenir. And very surprisingly, this time we got the Souvenir well in advance, 2 days in advance in our hand. So there were no tensions actually of distribution. Of course, with that, we also received the kits, delegate kits, which were prepared by Sagar Patekar and his team. So thanks to Sagar, as well as thanks to Rajiv Sant, who printed this Souvenir, who had been printing IWA's material for last so many years. Heartfelt thanks to all the speakers and the session chairmen. Sir, all of you have come by sparing your 2 or 3 days of time, and then you really contributed and then enlightened us with your experiences, your background, and your well-earned knowledge. So that will be definitely carried, as said by Dhaval, and then we will have a way forward in the form of a booklet of this conference. The Mitra team as well as the MJP team also supported by Engineer Vaishali Patil, and then Narode Madam, and then of course Ubale Sahib. Tripathi ji was always there as a backbone of this facility, and then he supported and did excellent arrangements for stay of all the council members. Then we also got the support from Jal Shakti Ministry, so thanks to Jal Shakti Ministry for supporting this conference. Support is also given by All India Institute of Local Self-Government. So thank you Chekala Madam and the Jairaj Patak and all for supporting this event. Then all the engineers and sponsors and advertisers for this event, you have really helped us to meet both the ends. Last but not the least, the delegates of this event, 2 days, you have been sitting and then gave us a lot of interactive sessions. Council members came in the big number of Indian Water Works Association as well as the past presidents. They also were here present. So our heartfelt thanks to them. The press and media people also there, they had excellent coverage in today's almost 10-12 newspaper. This conference has been widely publicized. So thanks to press and media. And also to the event management agency, Messrs. Azim Sheikh. He also did a good work. Even the last minute requirements were fulfilled and within no time. So that it is the amazing work done by him. I think we will remember for a long time the excellent food given by Sagar Suruchi caterer. So thanks to Sagar Suruchi also for the food served to us. And at the end, I would say that only please excuse if anyone is omitted here, but then thanks to one and all. And I wish a happy journey to all of you to back to your respective places, and see you soon at the convention or any other events in Coimbatore. Yeah. So thank you very much, and then we will have a high tea outside after this function is over. Thank you once again.